Hold on to the hand of self-destruction. And I'm back to a place that I left a long time ago. Just give me a sec while I smoke this cigarette. My aching body feels better still. What do you do when you pick up my guitar and too much on your plate when I need to escape? Everything will be better when I find a way. When people leave, do they ever think about you? What I'd say if I ever came back again. Well, I still wonder and I miss you. I know I'll ask you when I see you again, my friend. What do you do when you get the blues? Just pick up my guitar and too much on your plate when you need to escape. Everything will be better when I find a way. Oh. What do you do when you
Discovery, go at throttle up.
pick up a guitar and too much on your plate when you need to escape? Every little thing will be better when I find a way. Whoa, whoa, whoa. Find a
Good morning, everyone. Or good afternoon. Or good early morning for some. How are you guys doing? Morning, my old sunshine. We got a launch. Should be happening soon. A little blues jazz in the morning is very healthy. Yes. 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 Okay, SpaceX cast isn't up here, but the NSF cast looks to be up. So let's go see what's going on over there. Let's see. No signal. There we go. Go. There we go. There it is. Okay. So 18 minutes. That's the strong back chill down right there. That looks good. I'm doing good. As long as the Bathurst 12 doesn't get delayed a second time, I'll be in the area and able to go. Nice, nice. All right, so this is an NSF shot. Of Falcon 9 on Slick 40 at Space Launch Complex 40 at Cape Canaveral Space Force Station. This is the Transporter-3 mission. The Transporter-3 mission is what's called a rideshare mission for Falcon 9. Basically, there's a bunch of tiny satellites on this thing. It's not carrying one particular big satellite or a bunch of the same satellite like a Starlink launch would. This is all different kinds of small satellites, basically on a payload adapter that looks like a Christmas tree, and they send it all up at once, and they deploy all the satellites once the Falcon gets up on orbit. Once again, that's called a rideshare mission, where a bunch of smaller satellites are sharing one big launch. This is yep, Zabby, that's right. This is an RTLS mission. So that Falcon 9 is going to attempt to land back on land. It's not going to be a drone ship landing. These seem exceedingly rare nowadays. We see a lot of drone ship landings, especially since the majority of the Starlink launches are with Falcon 9 landing out on the drone ship. So you don't really see these that much. The last RTLS landing was Salcom 1B, which was a polar trajectory out of here, if I'm remembering right. This will be the 10th flight for this Falcon booster. Yeah. And the fairings will be recovered. Yep. 105 spacecraft on board. Deployments will begin at T plus 59 minutes and 38 seconds and will end at the T plus 1 hour, 27 minute and 4 second mark. There you go. Sweet. So once again, this is the NSF cast. You can see that they just chilled down the strong back right there. What does that mean in plain English? They're priming the fuel lines so they can fill the second stage up with fuel and oxidizer. Basically, they needed to get them cold, so they start pumping propellants through them, right? And it chills down the line. And that basically makes it so when you pump the fuel up in it, it isn't going to get heated at all, and it goes up the pipes cold and into the rocket cold. You don't want the liquid oxygen going up this thing and exchanging heat with the air, right, causing, condensation. You don't want, and then it turning to gaseous oxygen. That would be bad. It is a liquid fuel engine. So they do have the purge line open right there. And coincidentally, that's the same line that will release pressure from the strongback, getting all the fuels out when they're ready to launch in a second here. How do they get it down with a rocket engine? So let's go over here. Let's see if the SpaceX cast is up. Transporter-3 mission. Nope, not yet. Only put gas in the car. Indeed. Probably the coolest payload on this mission. NanoRacks is testing a concept for a wet workshop. Mars Outpost demo is an experiment with the overall goal to demonstrate metal cutting in space and to explore the feasibility of reusing abandoned space vehicles. That is cool, actually. All right, let's go over here. SpaceX cast is up. Let's see what we got. It's early. I need coffee. Like now. There's no one inside. No. This is launching from pad number 40, Dawson. 40 cannot support launching people. 39 is the one that launches people. So no, there's nobody on this. Get some beans in you. I will, mate. If they pump LOX through the veins in the rocket nozzle, how do they keep those veins from clogging or exploding? Well, Ben, that's a super complicated question. Usually it's milled copper channels, or there are other ways to do it. Certain rocket engines are basically, like an RL-10 for instance, You know, like, okay, picture the Old West in your mind, like the cowboys and, you know, Native Americans and stuff, right? Howdy, partner, right? Like, you know the barrels? You know the barrels that are a bunch of pieces of wood, and then they have the iron collars around them to put the barrel together? You know what I'm talking about? Some rocket engines are made exactly like that. It's literally a bunch of steel pipes that are wrapped around in a circle. It kind of ends up looking like a teepee, and then they just have bands that hold them together, and they pump the liquid oxygen through the pipes. That's what an RL-10 does, or in RL-10's case, it's liquid hydrogen. But yeah, some are made like that. Now they have a machine solution. But in terms of not getting them clogged, pressure keeps them from getting clogged. Yeah, it's pretty cool. There's a lot of cool things that you can do to keep the pressure from messing up. But long story short, like, from the turbo pumps to the chamber pressure, right? The pressure has to be increasing. The pressure always has to be increasing as you go further and further downstream. Or no, it's decreasing as you go further downstream, excuse me. So the turbo pumps need to have more pressure, and between the turbo pumps and the engine, you'd have your cooling channels. So they're at extremely high pressure. Higher pressure than the chamber. Because think about it, right? If you have lower pressure in the turbo pumps than you do in the combustion chamber, it'll backflow. It won't work. It needs to be all downstream. Or you need to have exceedingly lower and lower pressures as you get further into the rocket engine. And when you get out the bottom, that should be the lowest. So from like turbo pump inlet to exhaust nozzle, right? The pressure should go down. That's hard to do, man. That's very difficult. Yeah, it's decreasing. Sorry. It's still early. You're going to have to bear with me.
Discovery, go at throttle up.
I mean, think about it like a fire hose. A fire hose shoots out water really, really fast. I mean, the funny thing is that a rocket engine makes a fire hose look like a freaking straw. like a not plastic straw. Let me put it to you like that. Rocket engines move insane amounts of liquid. They like turbo pumps on a rocket engine, on like a Merlin 1D, could drain an Olympic swimming pool so quickly you'd be able to see the water going down. That's really fast. Like they can move. They can move propellants very, very fast. So pressure is how they keep them from getting clogged up. But the other thing, Ben, that you have to take into account is that if you're using liquid oxygen, super, super corrosive. Oxygen makes stuff rust. It oxidizes things. I know. Oxygen oxidizes things. Whoa! Huge breakthrough there, man. It does. It oxidizes things. And so what they got to do, usually if you're going to reuse the engine, like SpaceX, for instance, they got to back purge the engine after they shut it off. You got to purge it out. Or else, yeah, you're not going to have a good day. The space shuttle engines had to do the same thing. They had to dry the RS-25s after testing. When you launch it up into the vacuum, it dries out because there's that whole vacuum thing. It's more corrosive than Geeson's puns against the brain, indeed. That's the thing that's really impressive. However much force is coming out of a combustion chamber, there's the same force pushing back on the turbopumps, and they still pump into it at crazy speeds. Yeah, it's pretty ridiculous, right?
LWO1 WeatherNet, liftoff conditions.
Looking pretty good. The shortfall of Gravitas is leaving port for the January 18th Starlink mission from 39A. SpaceX isn't slowing down. Good.
Falcon 9 has cleared the tower.
Fast forward.
10, 9, 8, 6, 5, 4, 3, 2, 1. Good morning. It's Thursday, January 13th, and we're here at SpaceX headquarters in Hawthorne, California. You're looking at a live view
Okay.
of the Falcon 9 as it awaits its 10:25 a.m. Eastern Time
Here we
launch
go.
from
Here we
SpaceX
go.
Launch Complex 40 at Cape Canaveral Space
Start
Force
the day with a
Station in
launch.
Florida. My name is Kate Tice, and I'm a reliability engineering manager here at SpaceX. Welcome to the webcast for SpaceX's Transporter-3 mission, our third dedicated smallsat rideshare program launch, and our second launch of 2022.
Me neither, Nick.
With today's flight, Falcon 9 will deliver 105 spacecraft, including microsats, CubeSats, pocket cubes, and orbital transfer vehicles to sun-synchronous orbit.
We gotta go to Bendigo,
There will be a
Morty.
total of 82 deployments,
Gotta get in the
which
cube,
will begin
mate.
around the T+1 hour mark and last for approximately 30 minutes. Now, due to the lack of ground station coverage at times and the position of our camera, we only expect a handful of our deployments to be visible today. However, we do expect to have telemetry and hear audio confirmation over the nets when in range of ground stations. To see the full list of today's deployments, head on over to SpaceX.com. With liftoff in just over 8 minutes from now, let's take a look to get acquainted with the rocket on your screen.
Hello, Rain. Hello.
Our two-stage
Hello.
launch vehicle stands about 70 meters tall when fully fueled. It'll hold just over 1 million pounds of propellant that the vehicle will burn through in less than 3 minutes after liftoff. The first stage, which is the bottom 2/3 of the vehicle, you can see it there on your screen, is the booster which has 9 Merlin engines that do the bulk of the work to get Falcon 9 off the ground
Very
and
low,
up to the
Sile. It
thinner
really
parts
depends.
of the Earth's atmosphere.
Could be as low as
At about
a couple
2.5
mil.
minutes into flight, it'll
pretty good.
separate and make its way back to Earth and target a land landing back at landing zone 1, which you see there on your screen. Today's mission marks the 10th flight for this particular booster, which debuted in May 2020 on our Demo 2 mission to the International Space Station.
9 times prior, right?
You will notice the soot left over from its previous 9 flights. On top of the first stage is the black carbon fiber inner stage. It connects the 2 stages and houses the pneumatic pushers that allow the first and second stage to separate during flight.
And they have multiple
Then on top
boosters
of the
that are
inner
up at
stage
9
is
flights.
the Falcon
One
9
of them's
second
at 10.
stage, and that will take the payloads to their eventual destination in orbit.
Capybara.
After the first stage separates, the second stage
agree,
will then
Sebby.
carry the 105 spacecraft to orbit. Right now, those satellites are enclosed inside the large
Yeah.
nose cone that you see there.
Lid on.
It's located on top of the rocket, and this is called the fairing. Its job is to protect the payload until the vehicle is outside the Earth's atmosphere, at which point the fairing separates to expose the satellites to space. Today, we're flying a brand new fairing, and we will be attempting to recover the halves from the water once they return to Earth.
You can
The chief
see
engineer held
Kennedy
a
Space Center
technical
over there,
poll
by the
at
way.
T-1 hour, and the launch director held a propellant load
That's
and
KSC
launch
Industrial
go-no-go
right
poll
there.
at T-38 minutes. Since T-35 minutes, Falcon 9
Just
has
saying.
been loading
It's a
propellants.
really nice picture.
Falcon 9 is a bipropellant vehicle.
Oh,
The
gimme.
fairing separates to expose the satellites to space.
All right, we gotta fast forward.
Today, we're flying
Prepare to
a
fast
fairing,
forward.
and
Prepare
we'll
to
be
fast
attempting
forward.
to recover
Fast
the halves
forwarding,
from the water
sir.
once-
Will they keep any special conditions inside the fairing, like cooling? Every single rocket has HVAC for the fairing, man. Every single rocket. Payloads aren't designed to operate down here. And for a brief moment, you gotta keep them on down here. What's up, Greg? How you doing? Here, let's just... Wow, the picture looks like it's interlaced. That's very strange.
Discovery, go at throttle up.
Hey, Tech gifted us up to Forge. What are those buildings on the crawlerway? This is the ITL complex. That's not the crawlerway. That's ITL. This is Cape Canaveral Space Force Station side of things, guys. Those buildings are... The first one on the right from the camera that's up on the tower, it's the Space Operation... It's called the Spock. I forget what the SPOC stands for. And then that building... the building behind... That one right there is the Solid Rocket Motor Assembly Facility. The SMARF is what it's called. SpaceX actually integrates their payloads for Slick 40 in there. That one is the Spock right there. That's where Vulcan is. Vulcan's mobile launcher is in that building. Yeah, ULA uses that building. And then over there at the very back, at the very bottom of the ITL, that's right there is Atlas Space Operations Command, ASOC, right there. That's where they launch Atlas 5s from. That's the launch control center for Atlas 5s that launch on Slick 41, which is that way. You have a meeting in 10 minutes. Well, the launch is in 3, so you're good.
There on your screen, you can see our strong back.
Yeah, this is the Space Force Station side of things, side of the Cape. But yeah, those buildings are still cool. A lot of history there. All this infrastructure, guys. So Slick 40, Slick 41, Spock, the SMARF, the ITL Causeway, and the Integrate Transfer and Launch, which is what ITL stands for. That's all former Titan 3 stuff. And it was built in the late 60s, so the Air Force could launch spy satellites into space. They were originally utilized for Titan 3. Well, it started with Titan 2A, and then Titan 3, Titan 3A, Titan 3C, Titan 34D, and then I think Titan 4 after that. Yeah, lot of rockets launched from these pads, and a lot of rockets still launch from these pads, which is good. That's a good thing. Use them. Launch more things. Space Operations Command. Yeah, that's what I thought, Rain. I didn't want to guess, though. I know it's called the Spock. That's what they call it. Vulcan's mobile launcher is in there. I know some of the guys that built the launcher in that building, with some of the crane operators, which is actually pretty cool. Spy satellites! What's up, A-Tran? How you doing, man? Bro, it looks nice. Nice and crisp down there, man. This looks like it's about 65 degrees out, something like that. Nice crisp day in Florida. Love it. I miss it so much.
I mentioned before, our satellites are
Spock and Vulcan.
Inside
yeah,
the
that's not a
fairing.
coincidence.
They
A bunch of
continue
nerds,
to be
Rain. What do you
healthy.
want?
Team is tracking no issues on the rocket.
EJ says launch more things.
And as a reminder, if we don't launch today,
hold my white claw.
we do have a backup opportunity tomorrow at the
Rogue
same
newbie,
time.
what's up? What was your question? I just joined. What are they
We have
launching?
just
100
2 minutes to go before launch.
105 small satellites. It's turbocharged. This is a small sat launch mission, so it's called a ride share. Basically,
on the second stage has
there's no one big payload up here. There's literally a Christmas tree, and all the decorations on the Christmas tree are a bunch of small satellites. Yeah, it's a very strange mission. You don't see these very often. But hey, you know, if 105 companies want to share a Falcon 9 launch, that divvies up the price of a Falcon 9 something fierce. And if it's reused, the price goes down even lower. So these rideshare missions are one of the cheapest ways for a small company to get a satellite up into space. All right.
The flight computer has taken over.
Nice, Forge. That's cool. Thanks. And awesome. Yeah, Rogue Nibby, it's cool. Nice morning launch. Shouldn't have been a choo. I don't know, maybe. Fun fact, I have a buddy who was a civvy working in San Diego shipyards maintaining the nuclear reactors on Navy ships out there.
Falcon
But he got hired by Blue last year and built
at this
the
point
engine
in
that will
time,
fly
stage
the next
1
new
and
Shepherd.
stage 2
Cool.
are beginning to pressurize
Nice, Rav.
for launch.
Sorry, it's taking me a second to get going, guys. It's early for me.
Go for launch.
Okay, we are go.
And there was our final go for launch today from our launch director.
How do they integrate the rocket to the Strongback?
With
With a crane, Ozzy.
30 seconds. All
The
systems are
Strongback-
go for launch.
30 seconds.
The Strongback is horizontal,
listen in to
and
the
they
final
just
countdown.
pick up the Falcon 9 and they sit it on it. Yeah, there's little holders. You can see them. 1, 2, right there. That hold the rocket in position. But I'm gonna shut up because it's time for launch, baby.
T-minus 15 seconds.
15. Turning it up. Crank it
10,
up.
9, 8, 7, 6, 5,
Sound suppression is
4,
activated.
3, 2, 1, 0. Ignition and liftoff.
Everything looked good. We flying today. Oh,
Vehicles pitching downrange.
That's nice.
Pressures are not.
Oh, that shot though. Oh, keep this camera, please. Look at, there's Slick 41 over there on the left. Vehicle is completed a roll pitch now.
Power and telemetry nominal.
Power and telemetry is nominal from Flight Dynamics.
All right, as you can see, Falcon 9 has cleared the tower, lifted off from Cape Canaveral Space
9 is
Force Station.
supersonic.
We just heard the call out that the vehicle is supersonic. We're currently going to throttle down the engines in
Saw
preparation
39A
for
and
max
39B
Q
over there.
coming
Max
up.
Q.
Oh, there we heard it. So that was the moment of
Rocket
greatest
launches look so
aerodynamic
violent.
pressure
Oh,
that the
they're
vehicle will experience in flight today.
They're
Everything looking nominal
violent.
with stage 1 trajectory. Now we have 5 events coming up in quick succession. MECO, or main engine cutoff, stage separation, stage 1 flip, second engine start 1, and the boost back burn. And you can follow
there
along
for-
with those
it's
events
cool.
there on the timeline
you
at
get
the
bored
bottom
of
of
this?
your screen.
Get bored for me. I
Beautiful
love it.
view of the Florida coastline.
Yeah, you can see all the way up to
Main engine
Daytona.
cutoff coming up in just
Look at
under
this thing's
30
flying
seconds.
due south. Yeah, see, look, Daytona's up there.
As I mentioned before, we will be landing,
speedway?
attempting to land the booster back on land at landing zone 1.
Maybe. Oh, there's the
This
airport
is known
right
as
there.
return to launch site, as opposed to a drone ship
All right.
landing.
We saw it for a second. Roundabout's like, I can see my house from here. Ah, it's okay, boss. You didn't miss the best part.
MECO.
Stage separation confirmed.
Oh! No! No, go back! No! Yeah!
Back startup.
Stage 1, boost back.
Oh, that's pretty good. That's pretty good. Oh, that's pretty good, man.
So you
Oh!
can see there on the right-hand side of your screen, second stage MVAC engine has ignited. The first stage on the left-hand side is
I don't hate
performing the boost
Go and
back.
throttle up.
And the second stage is doing
which,
the
as you
dog
saw
leg.
just moments ago.
So,
the first stage.
If you saw the second stage looks like it was kind of turning. That's because it is. They launched this thing due southeast, like south-southeast, and then when they separate, the second stage takes a right and it just follows the coast of Florida down south, which is nuts. It's really, really cool. It's a really cool mission.
On the right-hand side of your
Oh,
screen.
did you see the first stage turn, man? Oh, that was so good. That's why I woke up for this. Yes.
Stage 1, boost back shuttle.
All right, so there we heard the call out that the boost
launch
back burn
director's
has
microphone is not plugged
concluded.
in.
That was the first of 3 burns that the first
What was
stage
that other
will perform
question?
today.
No, this is not.
And
This
we
is
can
not
see the
Starlink's
grid
Zelda
fins
This is a
beginning to
rideshare
deploy
mission. Oh.
there on the left-hand side of your screen.
Uh,
The next
helium for
event
those
we have
thrusters?
coming up
Nitrogen.
is fairing deployment.
Watch the fairing. Ready? Boop. Clamshell fairing. Bye bye.
All right, there you can
Look
see
at-
the
look
2
at- see?
fairing halves.
See all the
have
satellites?
separated,
It looks like a
fallen
Christmas
away from the
tree.
vehicle, exposing the 105 spacecraft to the vacuum of space. As a reminder, we will be attempting to recover these brand new fairing halves.
Look at this shot. You getting vertigo yet? Look at this shot. You getting vertigo yet? Oh man, look at the coast of Florida. Holy crap, dude. You getting vertigo yet? Bro. Oh my goodness. The Cape should be coming into view here. Up top.
From the first stage there on the left-hand side of your screen,
We should see
and the second stage on the right.
a picture of the interstage.
The first stage booster re-entry burn.
No, it's landing on the pad, Vext.
To slow it
So that means we should get a signal all the way down. You see some solid nitrogen coming off there. Okay, all right, there's Satellite Beach.
unnecessary strain on the rocket. There we can see the east coast of Florida.
Holy crap, look at that. There's Cocoa Beach, there's Port Canaveral. Look at that. Holy crap, this thing is landing right there.
Once again,
See where my mouse cursor is? It's landing right on that point, right where my mouse is. It's going to be down there in a second. Look at Florida. Oh my goodness. Well, that doesn't suck.
mission of 2022.
What the frick?
SpaceX is targeting at least 3 dedicated rideshare flights.
See, you
to
can
sun
see the
surface
landing
orbit
pad.
per
That's
year.
it right there.
And we
Oh,
also
where my mouse
offer
cursor is.
opportunities for a ride to orbit
That's
on our
Complex
Starlink
13
missions,
right
which
there.
launch
And then you
every
can see
couple
Slick
of weeks.
36 right there. That's Blue's
Small
pad.
sats can ride to space on SpaceX's Falcon
And then there's
9,
39A and 39B right
as
there.
well as Starship
And then
in
there's the
not too
VAB.
distant future.
Oh, that's so cool. Look, you can see all of Orlando. There's downtown
On the
Orlando
left-hand
over
side of
there.
your screen,
Oh
we
man.
can see those grid
Can
fins,
can you put like a
have
passenger
deployed.
seat on this?
Falcon
Man, this
9
view must
has
be
4
great.
hypersonic grid fins positioned
Look,
at the base
there's Winter
of the
Park
inner
right there.
stage,
There's
and
UCF.
they orient the rocket during
Oh,
reentry
that's
by
cool.
moving the center of pressure.
That's really freaking cool.
We can also see some white puffs of gas coming off.
Now you
from
really
Falcon
can
9.
see my
Those
house.
are cold nitrogen gas, which help with attitude control.
Yep. Watch these grid fins.
After
They're gonna
first
start
stage landing, the second stage
wobbling
will cut
around
off
from the
its MVAC
aerodynamic
engine
pressure.
and relight it approximately 45 minutes later for deployment of all 105 spacecraft.
So the pad it launched from is like right over here. You can't.
As for
It's
first
behind
stage,
the rocket.
its next
here.
event is the entry burn.
Watch the grid fins. The grid fins are gonna.
Stage 2 FTS has saved.
Oh, that grid fin did
Stage
some
1
move.
entry burn startup.
Okay, there's the entry burn.
And there on your screen, we can see that
Supersonic
entry
retro
burn has
propulsion.
begun.
Oh,
Once
that
again,
is-
this burn
that is so cool.
designed
Does
to
NSF have the
slow
shot?
the booster down as it returns
Oh.
through the dense part
Oh.
of the atmosphere.
Oh, that was amazing. They didn't get it for a second though.
Stage 2 on nominal trajectory.
It's very, very rare that you get to see this
we
from
just
the
heard
other
there.
from on the
Entry burn
ground.
shutdown.
Okay, entry burn shut down.
continuing
Now the
good
grid
with
fins are
second
really going to
stage.
do work. As Falcon 9 gets back into the atmosphere and your ambient pressure goes up, these grid fins are really going to start steering this thing.
Targeting a land landing at landing zone 1.
There's Cape
The
Canaveral
first
Space
stage
Force
has
Station
just
proper
one more
right
burn
there.
left, the
Stage
landing
strip.
burn.
FTS is saved.
It
There's
begins just
LC5.
before touchdown and
That's
provides the booster a soft
Pad
descent
that
before
first launched
landing.
an American into space right there. See it?
About the same time that Falcon lands, we are expecting SECO, or second engine cutoff,
There's
one
Complex
of our second
36
stage.
right there.
Just a few seconds away from landing,
Stage
and
1 is transonic.
vehicles traveling around 900 miles
Look
per
at the grid
hour.
fins. Look at the
With
aerodynamic pressure
acceleration
building up on the grid
perspective,
fins. You see them
the span
shaking?
of less than a minute will have reduced from
Oh!
twice the speed
Oh
of the
my
jet
God.
Landing burn.
all the way down to
Oh
0
my
as
God.
the rocket lands. There's a view on the right-hand side
Stage 2 in terminal guidance.
of the landing back at landing zone 1.
Stage 1 landing like deployed. Stage 1 landing is confirmed.
As you heard from the call out there and from the cheers behind me, we have successfully landed this Falcon 9 for the 10th time. It's also the 102nd recovery of an orbital class rocket.
That was awesome.
Nominal parking orbit.
Freaking great. Oh, that
All
was
right,
so good.
We just heard
Oh,
their
my
second
goodness.
stage had a good orbit, so
Oh.
we cut off or shut down the MVAC engine on the second stage. And
See,
as
look
we
at
just
the
heard,
dog
we
leg-
had
dog-
good
dog
orbit.
leg? Nice.
So we're now going
Dog
to
leg
coast
right
for the next
trajectory.
45 minutes or so while we wait for second engine start.
See
2,
that?
or SES2.
It shot it out over
see
the
you back
Atlantic
here
Ocean,
at
and then it
around
took a
2
huge
plus
right
55
turn and followed the
minutes.
coast of Florida down. This thing flew like right over Miami, which is really cool. That was the 10th landing for that booster, by the way. Just putting it out there. That booster's landed 10 times now. Whatever. That was so good, you don't need to... My house shook again! They make it look so easy. I know, man. That's so difficult to do. Oh my goodness. Okay, you want like maybe like 100,000th of the difficulty for this? Try landing a booster in KSP. Try doing it. You want it like 1/1000th of the difficulty is trying to land one in KSP. See how hard that is to do. It is very difficult. And they're just doing it like no, but alright, just another day. They got it down now. Oh, what is so damn cool. It's so freaking cool. You know what? Hold on.
We'll have,
Just
as we just heard there,
Stage 1 entry burn shutdown.
everything continues.
Just
A minute will have reduced from twice the speed of a
Stage
jet
1 landing burn.
all the way down to 0 as the rocket lands. There's a view on the right-hand side
Stage 2 in terminal guidance.
of the landing back at landing zone 1.
Stage 1 landing like deployed. Stage 1 landing is confirmed.
Alright. I've said this a bajillion freaking times, guys. I've only missed maybe one Falcon launch since like 2013. I've watched every single one of them. Every single one of them live except for one that I slept through, but that's another story. And I've said this a bajillion freaking times. That stage is 150 feet tall. 150 feet tall and about 15 feet wide. So it's 3.7 meter by, 50? It's not small. That is the size of a 15-story building right there. Just lands. Whatever. Just land. Yeah, okay. This is normal. This is normal in 2022, I guess. All right. Yeah, I know, hypersonic. My mind will melt when that happens. I'm 1 hour away and your house shook like crazy. Hell yeah, Krusty. Hell yeah. Are you on the coast by any chance? Because this thing flew due south. So if you're in like Satellite Beach or Cocoa Beach, this thing rocked the house, baby. Scary. That was, oh, dude, we gotta go back to the separation footage. I need this in my life. I need more of this in my life. Just. Bruh. Oh, that's so cool. Look at the first stage turn around and fire its engine. What the frick? Look at, you can see it. Oh, wait, hold on. Back it up. Give me 1 second. Watch. Look at the lower left corner of the right shot. Look, there's the first stage. Oh, that's so good, man. Oh, that's so cool. Oh my god. Oh, yep, off to space. Bon voyage. Oh, that's so legit, dude. I'm sorry, I've watched this a bajillion times. That's never not gonna be cool. Oh. And also for the Cocoa Beach, Satellite Beach folks, that shot should look pretty familiar. Look, SR 528 right there, SR 401 right there, A1A right there. Is that crazy or what? Look at this picture, man. Look at this picture. 154 second stage. It performed good. Look at that. How's that for a shot? You could see all the satellite in Cocoa Beach. I know, yeah, you can see the dogleg trajectory. Oh, that's so good, man. Yeah, hang on. We'll prop this back up to live, and then I want to see what NSF got. Hold on. Oh. Oh, look at NASA spaceflight shot. Okay, Trent. Good night, buddy. It's pretty cool living here. I used to live in Winter Park, Clip. That's more west of you, but oh, I want to move down there so bad. I gotta convince Primo. I gotta do it. I gotta convince Primo somehow. My fiance doesn't want to move to Florida. I don't care what anybody says. I freaking love Florida. Florida's the best, man. Where else does this happen? Don't say California, all right? That's not comparable. Florida's better. Because they got Florida, man. All right? Florida. Texas. Okay, that's fair. You can say Texas. Oh, look at that. You can see the nitrogen thrusters firing. Oh, that's so cool. That's never not going to be cool. It's like a 1970 Charger, all right? You don't even have to like old cars. Everybody knows that a 1970 Charger is cool, all right? Everybody knows this. That doesn't matter. You don't even need to like cars to be like, oh, look at that car. Family, all right? That's never not going to be cool. Where did you move to? Boston. I grew up here, Clips. I went to college in Florida. Prefer a 65 Mustang. I don't. I'll take the 70 Charger. Lada is cooler. No. I mean, ladders are cool, don't get me wrong. Well, back to where it likes 71 GTO. 69 is better. You like the split grill clips? All right, that's fair. If I'm 67 Mustang, guys, that's my favorite. I don't need the Shelby. I just want the 67. That's fine. But my favorite is the turbine car because I'm a loser. Yeah. Yes, but are you a Gators fan? No. UCF. UCF is my adopted alumni, okay? Because I went to Full Sail, and they don't play sports at Full Sail. Full Sail does not have a sporting team. Full Sail stands on the sidelines and goes, yeah, sports! All right. Unsubbed. What? UCF beat them Gators, boy. That's right. That's right. Dude, look at this shot, man. Oh, man. Beat that Gator butt. Maybe not so cool news. Virgin Galactic getting new VP of Operations. Can't name the person. It's not official yet. Oh. All right. 74 2002 Turbo. Classic Euro, Sebi. Ja. Ja, ich glaube. Ja. Ist gut. Ja. 71 Hemikuda. I see you have good taste, FX. Gators had a trashy or bad coaches is my excuse. Yeah, coaching's a lot of the battle here. Dude, look at that. You can see all the way down to freaking all the way down to Fort Lauderdale. Look at that. Look, there's Miami. Frick you, there's Miami. Look, there's Lake Okeechobee. No freaking way. Yeah, yeah. Holy crap, what a shot. That's the Everglades out there. There are gators in there. There's a lot of gators. There's Miami right there. Miami, Fort Lauderdale, all the way up A1A to Port Canaveral. That's a long way. That's a long drive. Roundabout, your son's a senior at UCF or EE. Hell yeah. Dodge Ranch pickup. FX, you have very good taste in vehicles. I applaud your taste in vehicles. But I'd apply to NASA. Want me to talk to some people, Roundabout? I know some people. Just saying. How is it possible that collisions never happen with all the stuff in space? Space is big, Joe. It's big. With that being said, collisions happen all the time. You just don't really hear about it. Dude, there's a lot of... Space is not clean. It is not a clean place. There's a lot of junk up there. Not from us. There's a lot of... There's ice. There's a lot of stuff. There's ice. There's dirt, rocks, all kinds of crap up there. It's not as clean as one might think. And human satellites notwithstanding, there's micrometeorites all over the place. Most of the stuff is impact resistant that goes up there. Because there's like small marble-sized pieces of rock, and like not even a marble, maybe like a ball bearing or a BB-sized pieces of rock just floating around Earth. That they hit the space station all the time. They hit the space shuttle all the time too when it flew up there. Yeah, hits Dragon. Yeah, they're designed to be impact resistant. But how do we deal with it? Well, that's what the Space Force does, believe it or not. There's these things that the Space Force has called Space Control Squadrons, or Delta Control Squadrons is what they're called now. Because Space Force doesn't have divisions, they have deltas, which is cool. That's really rad. So, like, the 6th Space Control Squadron and the 18th Space Control Squadron are just for debris tracking. Because one of the Space Force's stated goals is Space Debris Management, or SDM, and Space Situational Awareness. SSA is what it's called. So literally there's guys with radars and telescopes that just track all the debris. And they can track a debris down to maybe the size of a wrench. It's pretty impressive stuff, to be honest. Supersonic retro propulsion. Yeah, wait, we got a business end shot of SSRP. That's not something we usually get all the time. Hang on. Is the Tesla car still up in space? Yeah, Clips, it's up there. It ain't coming back anytime soon, dude. We're, that Tesla is in a... Okay, Clips, I'm gonna nerd the hell out for a second, okay? That Tesla is in a slightly eccentric, heliocentric orbit with its perihelion is at 1 AU, and its aphelion is at like 1.8 AU. So, okay, what does that mean in plain English? It's in an egg-shaped orbit around the sun, and the highest point in the orbit is somewhere near Mars, and the lowest point in the orbit is somewhere near Earth's altitude. Earth and Mars are in relatively circular orbits, so when I say 1 AU, that's 1 astronomical unit. AU is the distance between the center of the Earth and the center of the sun. Simple as that. So the Roadster is floating around the sun, a long way away. But it's up there. It's probably melted. The sun probably melted it. Even that far out, it probably melted it. If you live in Florida, you know that the sun eats through your paint pretty badly. Yeah, it'll eat right through the clear coat on a car, right? It'll eat right through it. It does that in space, only a lot worse. Yeah, because there's no atmosphere in the way. It'll just melt it. Oh, look. Hey, that's a nice heat shield over there. Yeah, it'll melt. The sun will melt everything that isn't like rad hardened up there. Oh yeah. That's part of the reason why aluminum spacecraft, like the ISS is made out of aluminum, most of it. It's aluminum is actually really good at dealing with that stuff because it's really good at dispersing heat. That's why radiators in cars are made out of aluminum, for instance. So yeah, it probably melted all that stuff off. Yeah, space is a very violent place. Only small hint, the new VP is coming from quite famous rat. Okay, Baz. I don't know where you're getting that information, but all right. Yeah, James Webb. That's a very good example. So that gold paper stuff is to protect it from the sun. Yeah, they use Mylar wrap on stuff, sirs, for thermals, yeah. The thermals are used for different things. They're either used to keep stuff cold or keep stuff hot. It's one or the other. In the daytime, in space, you're at like plus 200 Fahrenheit. At night in space, so when the Earth, like if you're orbiting around the planet, right? At night, you're like minus 200. It's like a 400 degree delta between day and night. And think about this. A spacecraft that's orbiting up in space, right, goes through these temperature changes every 45 minutes. That's a lot of fatigue on metal. So making stuff out of aluminum actually isn't a bad idea because the aluminum is very good at not dispersing. It's very good at spreading around heat and absorbing it. It's really good for that. And it also absorbs radiation too, pretty damn well. Actually, it doesn't absorb radiation. That's not the right way to say that. It bounces radiation, which is very important to understand. Everybody asks like, oh, how did the Apollo astronauts get out there? What about all the radiation? Well, their spacecraft's made out of aluminum. Aluminum bounces the radiation really well. It doesn't absorb it. Because, like, you don't want a spacecraft that absorbs radiation. That's bad. Having a spacecraft in space that's made out of, like, lead would be very, very, very bad. That would be like making a boat hull out of a sponge and hoping you don't get wet. It's not going to work that way. It doesn't work like that. You don't want that. It was our TLS anesthesis. You want to see it? Dude, we had the gnarliest shots. That's why I just have it on replay. Look at this.
The speed of a jet,
landing burn.
all the way down to 0 as the rocket lands. There's a view on the right-hand
Stage 2
side
terminal guidance.
of the landing back at landing zone 1.
Oh! What is RTLS? Return to launch site. That's some golden hour stuff right there.
Stage 1 landing like deploy. Stage 1 landing is confirmed.
As you heard from the call out there and from the cheers behind.
All right. Yeah. Okay. That's a thing that exists. My favorite part of this, guys, is check this out. The rocket engine, look. The rocket engine flames are so ridiculously hot. When this thing is coming down, it's actually heating up the vapor, the humidity in the atmosphere. It's heating it up and it's propagating around the flames because the water's turning to steam. It's heating up all the water vapors in the atmosphere. You see that? And then the aerodynamics of the booster are pushing that water vapor away because air is compressing up against the sides of the rocket. That's why it pushes it out. It's so freaking cool. Look at that. That's literally just boiling off the atmosphere. That's what Florida literally does almost every day. That's why it rains so much. How effective are the grid fins at low altitude when it's about to land? I assume the gimbal takes over at some point. That's absolutely 100% right. These are hypersonic control surfaces, Nick. They really don't work when you get into subsonic very well. I mean, no better than any other control surface would. Yeah, it relies basically on gimbal.
Discovery,
From when the grid fins start doing this, all gimbal. Watch the gimbal on the engine. Yeah, see, these grid fins aren't doing anything, but they're really not doing much. It's all gimbal steering it in right there. There's a point of relative instability for a rocket. And when I say instability, I don't mean that like it's going to blow up or something. I mean, it might, but rockets, when they're basically going below like between 0 and like 200 miles an hour, or what would 200 miles an hour be? 320 kilometers an hour. There's a relative unstable point because the only thing that's going to stabilize the rocket is the rocket engine gimbal, the thrust vectoring on the gimbal. Same thing coming down as going up. So that's why if you watch rocket footage in slow motion, sometimes the rocket kind of slews off the pad a little bit. It's very obvious to see it with a Saturn V. If you watch the Saturn V launch, it kind of veers to the left a little bit. That just happens. It veers off just a little bit, and then once it starts speeding up, the natural aerodynamics kind of stabilize the vehicle. Think about it like a bullet. If I took a bullet and threw it, it would just spin end over end. But if you shoot it out of a rifle, it's spinning and it's going really fast. It stabilizes, right? So rocket's kind of the same way. So it's basically a big bullet that shoots up into space. Only the gun is attached to the bottom of the bullet. Yeah, good enough. Does lower thrust to weight ratio off the pad accentuate that effect? Correct. That's why it's so apparent with the Saturn V, because the Saturn V had like 1.1 thrust to weight off the pad, meaning that the rocket engine's upward, the upward acceleration on the rocket engines was barely enough to overcome the force of gravity. That's why the Saturn V is really slow off the pad compared to other rockets. Also that.
Stage 1 landing is confirmed.
As you heard from the call out there and from the cheers behind me, we have successfully landed this Falcon 9 for the...
That's the 10th flight of that damn booster. Whitney? That's a Space Explorer raid. Whitney, just... Oh, bonjour. Oh, it is like fine cheese and wine. Look at that. Oh my God. That's amazing. I like that. I like that a lot. Yeah, that's the DM2 booster. That's right. EJ, the grid fins probably stop working below Mach 1. They work a little bit, but they don't work very well in subsonic. But yeah, that's just... Yeah. This is a baguette invasion. Surrender your boosters. I mean, the rocket basically does look like a flying baguette. I mean, it's true. What's going on, Space Explorer Raiders? Whitney, so Space Explorers is a French STEM streamer. Whitney, she does the same thing that I do, only with in French, which is pretty dope. That Malbo, now that's a baguette, man. Now I want some French bread, man. Yeah, see, it's toasted. It's even toasted, lightly toasted. It's perfect. Salutations à vous. Merci, Fred. Merci. What's going on, guys? You guys watching the launch? We're just looking at the footage again. It's just... EJ, will that rocket engine run out of fuel? Yeah. 10 times toasted, indeed. It is a reusable baguette. Oh. French Duolingo stream? Hypersonic, being close to Montreal, I pick up more French than you might think. Bonjour. Merci pour la école. Now see, Dara, I didn't understand that. I thank you for streaming? Yeah, I would guess. Just missed it. I've forgotten the time. Flam, watch this. The launch was great. This is all you need to see. Watch this. Just...
Stage separation confirmed.
watch this.
Discovery, go at throttle up. Transporter.
One, boost back.
So
that's the first stage turning around and going back to the landing site, and the second stage keeps going. And then look at the land behind the second stage. So there's the Cape right there. You can see all the way up to Daytona and even up to Jacksonville up there, which is nuts. That's a long way away. You can see all the way up into South Carolina. That's a long freaking way. Watch the terrain. The terrain's going to shift. It's going to move because the second stage is at separation. The second stage is doing what's called a what would it be? It would be a coplanar normal burn. So it's taking a right. So they launched this thing out over the water, right? And if you looked at its trajectory on a map, like if this is Florida right here, right? The thing went out and then it went down. And you could see the second stage taking that right-hand turn to be able to get into the correct polar orbit. Watch the terrain behind it.
The left-hand side.
Oh, that's cool. That's cool. That is a coplanar normal burn right there.
The first stage.
It's cool to see. Like if you play Kerbal, you do this all the time, but you see it in real life. It's like, oh, that's pretty neat. Oh, warm welcome. Oh, all right, hypersonic. Hell yeah, man.
Everything looking.
We French are jealous of Florida's clear sky because it's often cloudy in Kourou. Kourou's all right, man. Hey, you guys did good with James Webb. Seriously, good job. I was a little worried because of some prior Ariane footage, but there was a true return to form. You guys did fantastic. Excellent. Perfect. Magnifique. What was that very recent mission where the dogleg was near equatorial? I don't know, Scary, but that was a coplanar. That was a coplanar. No, that was anti-normal. That was to the left, not to the right. Ariane made you proud. I'm looking forward to Ariane 6 personally. Fairing separation. Oh, man. Ariane 6 is gonna be nice. Those P120C boosters on the side are gonna make that thing go real quick. I like that. Oh, it's time to wake up.
Currently in the first of two.
When is the next launch in Central Time?
8 plus 8 minutes and 20 T plus 8 minutes. And
4 p.m. this afternoon. Honey Piston, actually. Second stage coming over Finland. Here, I'm gonna switch us over to live. That's not Finland. That's Antarctica. But anyway, Whitney, thank you very much for the raid. I do appreciate it. Space Explorer Raiders, thank you very much. Yeah. Space is awesome. It doesn't matter the language. That's irrelevant. Very. Oh, man. What about my coffee, Dawson? Really? Another launch today? Oh, yeah. Yeah, Clips. Yeah. You want to see the launch pad? Here. Yeah. That's the launch pad right there. Yeah, the launch pad. So there's this company called Virgin Orbit. Virgin Orbit is owned by the Virgin Group, but it's not Virgin Galactic. Okay? Virgin Orbit is a small sat launcher. That's the launch pad. They use the 5th pylon on a 747 to shoot rockets up into space. I'm serious. It is the coolest thing ever. You see the 5th pylon? 747s, a lot of people don't know. They can carry 5 motors on them if they need to. They can deadhead an engine, and the idea was if a 747 goes somewhere, because it can fly a long way, if it goes somewhere that doesn't have an engine on hand, right, so an airport that's very remote, they can just send another 747 and they can attach another engine as a deadhead. And then that 747 will bring the engine to fix the other 747, and the 747 deadheads back to a maintenance facility with the broken engine on it. They have a 5th mount for an engine. Not a lot of people know that. Now, what Virgin did, they took that 5th pylon, since it's strong enough to mount a motor to it, they took it and they mounted a freaking rocket to it, because they can. So stage -1, the runway, yep. Yep. I don't know, S, but I've seen this thing, dude. It's based out of Long Beach Airport, which is really cool. I drove by it with the truck. That's the only 747 ever to launch a missile. It certainly illustrates the diversity of the platform. 747, they broke the mold with that thing, man. And don't get me wrong, I like my A380s too, but that thing, A380s didn't carry a space shuttle, okay? Alright? They're good. They're good planes, but they didn't carry a space shuttle. Okay? Dreamliner's good, Animal. Like, I'm a Boeing fanboy, dude. Sorry. I'm not. Did I miss the launch? Oh, yeah, Penta, you did. You missed a freaking treat, dude. I'll show it again. You got, dude. Oh, you missed a freaking treat. The launch and everything was fine, but what you want to see... What you want to see is this part right here. See last. What's up, Hypersonic? So the plane does a steep pull up like that at launch. What altitude? 30,000 feet? Yeah, 747 does this and then let it go and then it goes like that. Think like a B-29 with the atomic bomb. It basically flings the rocket up in the air and then they fire it. Oh man.
So you can see there.
Question, what's the difference between Virgin Galactic and a zero-G flight, except for the price? The altitude that it goes to, Tib. That's the big one. The Virgin Galactic Spaceship 2, that flies way higher than a zero-G flight. Zero-G flight's up at 20, 30,000 feet. The Virgin Galactic plane, the one with the rocket on the back, that goes to like 250,000 feet. Yeah, lot higher. Lot higher. Actually, it's actually closer to like, what is it? Yeah, no, 250,000 is pretty close. Close enough. Yeah, it flies way higher. The views are a little bit better. 747s, I'm feeling personally closer to Sophia. 747 SP. I see you're a man of taste. Here, Panther, you got to get to the next part. Watch this. That's a hell of a view of Port Canaveral, isn't it? Yeah, no problem, Tib. Yeah, it flies a lot higher, man. See, last question. Okay. Panther, you need to... It's very rare that we get supersonic retropropulsion from the business end. Please come back. What about the orbital ATK NG uses for Pegasus, the Stargazer plane? What kind of plane is that? That's a TriStar, man. It's the only TriStar that flies. It's the only one left. Okay, or the stream could take a dump. That works too. Here. One more RTLS for CSG2 later this month. Yeah. Watch this, Panta.
And provides the booster a soft descent before landing.
You want your mind blown?
About the same time
Watch
that
this.
Falcon lands, we are expecting SECO, or second engine cutoff, one
Passing
of our
PA.
second stage.
No, I didn't, Dawson.
Just a few seconds away from landing,
Stage
and
1 is transonic.
vehicles traveling around 900 miles per hour really puts the deceleration into perspective. In the span of less than a minute, we'll have reduced from twice the speed of a
Stage
jet
1 landing burn.
all the way down to 0 as the rocket lands.
Look at the rocket engine heating up the atmosphere. All the moisture in the
There's a
Florida
view on the
air is
right-hand
turning to
side.
steam
Two internal
around the
guidance.
rocket. That's what that
The
ring
landing
is.
packet landing landing zone 1.
Oh my god, that's cool.
Stage 1, landing like before.
How is that possible? How is that even a thing? Hypersonic, I've seen these things land. I saw the first Falcon 9 to land do exactly that. And it's dude, these pictures do not do it justice. Seeing that thing come back with your own eyes is the strangest thing. It looks wrong. Like, it looks wrong because think about like an airplane flying backwards and landing on a runway. That wouldn't look right, right? We're used to seeing rockets go up. Even now, I'm not used to seeing them come back down. It's very strange. That, dude, oh my goodness. The fine control, dude, the fact that they can get that pinpoint is unbelievable. Dude, with every Falcon 9 landing, SpaceX is proving to me that they can catch a booster out of midair. They can chopstick the booster in Boca Chica. I'm convinced they can do it. Oh. That is something else. It looks like it's leaning a bit. I don't know, Acton. Let me take a look. Just got to watch it again then. Yeah, polar RTLS Panther, yeah. So if you notice the pad is a little bit wet, they spray the pad down with water. And it looks like some of it may have dried up, but they spray the pad down with water to film cool it so it doesn't damage the concrete. Acton, that looks fine to me. Look at the horizon. Horizon with the vertical edge of the booster. It might be a little teeny weeny bit tilted to the left in this picture. Just maybe a little bit, but that's fine. It's no big deal. Can they stall out a rocket? That's basically what that does, Clayton. It stalls right above the ground. Falcon 9 doesn't land. What it does is it zeroes out its velocity as close to the ground as possible. Oh, jeez. Orange, that's crazy. Imagine being a bird when that thing comes back down. There are a lot of birds because this is a wildlife refuge. Because you can't put anything around launch pads. You can't put anything around them. You don't want somebody's house right here. That would be loud. I mean, I'd probably do it. You might have to worry about your vinyl siding getting melted though. But yeah, whatever. But because there's nothing around the pads and you really don't want to put anything near them, it's a wildlife refuge. So there is birds all over the place. There's actually an eagle's nest on KSC proper, which is really cool. You see bald eagles flying around every once in a while down there. Really, really awesome. And windows breaking. I mean, I've been close to a Falcon 9 when it was firing its engines for a static fire. Okay, all right, fine. We just get, just get a bunker, like not bunker, just a reinforced concrete building with some like ballistic proof windows. That'd be fine. Vinyl siding, brick all the way. Yeah. In Florida, the inside of that house would be like a kiln, man. It's no shuttle. Roundabout, I love Falcon 9, but the shuttle is Bay. The shuttle is. That's my favorite. I'm sorry. Like, look, the Saturn V is arguably better in every regard, except reusability, right? Saturn V is a way more capable vehicle around. I didn't grow up with a Saturn V. I grew up with a space shuttle. I love that thing. I love it. The space shuttle was the first thing that humanity's ever made where people look at it and say, that's a spaceship. That thing flies into space. That's what a spaceship looks like. It was our first icebreaker into the realm of science fiction. And when Starship flies, that'll probably be my new favorite. That's awesome. General Assembly. I remember that. Yeah, once Starship starts flying, man, that's when I can be like, okay, I love you, shuttle, but Starship is way cooler. You know? Have you seen the Russian version of the shuttle? Clips, I'm a space nutcase, dude. Yeah. Buran is what it's called. It's the Russian word for blizzard. And the booster that goes with it is Energia. It's the Russian word for energy. So the Energy Snowstorm launch vehicle. Yeah, I know a lot about Buran, man. Great rocket, great launch vehicle. Energia was a triumph of engineering, and I'm saying that even as an American, it was a great launch vehicle. The shuttle, I don't know. Buran, the shuttle is okay. It's okay. It's not bad. I mean, it's a shuttle. I like shuttles. I like the American shuttle more. I like getting my upper stage engines back. Yeah, if I had to choose. But Energia is a good rocket. It's a good launch vehicle because it can launch. You don't need to put a shuttle on the side to launch it. You could put a semi-truck or a steam engine on the side. It'll launch that into space, no problem. You put whatever you want. Anything up to 100 tons on the side of that thing, and it'll launch it into space. That's what makes that thing cool. If I had to choose, if it was up to me, I would take Buran's boosters, the Zenit boosters with the Energomash RD-170s. I would take those, and I would put them on the side of the space shuttle. So space shuttle, or the orange tank with the space shuttle, right? And then 4 Zenit boosters. And then I would have the Zenit boosters boost back and land. Now, before people say, that wouldn't work. Of course it would. Why wouldn't it? RD-170s can deep throttle because of the high stage combustion cycle chamber pressures. They can deep throttle just fine, just like a Raptor engine can. You could land them. You could. Yeah, yes, I would do that. That would be amazing. And you cannot tell me otherwise. You split the combustion chamber pressure over 4 nozzles. It can deep throttle. Of course it can. So can the RD-180, for what it's worth. Yeah. Oh yeah. That would be the ultimate launch vehicle. Can you imagine 4 of those things coming back down and landing? That would be pretty neat. That would be pretty neat. Do it in KSP. Peep your link. I'm guessing you've seen this vid. Dude, I have... Oh, yeah. Yeah, the Urbex video. Unbeaten Paths Urbex video. Yes, I've seen that video. That orbiter right there is called Burya. It's I forget what that word is for, but that's the second shuttle. That one was supposed to be the first shuttle to fly people on it. Because the one that did fly into space on the 1K1 mission in November 1988, it didn't have any life support systems on board. They were waterfall testing Buran, basically. They tested the launch vehicle first with Polius in 1987, and then with Buran in 1988. And then the next mission was supposed to be in 1990 with that. Maybe I think the next mission would have been with Buran in 1990, and then the first manned flight with that thing would have been with that orbiter in like 92 or 93. They were slow. They were going slow because building big rockets is difficult, and building big rocket shuttles is difficult. Yeah, that's the second flight test or the second flight article. So it has a serial number of 1.02, I believe. Buran, the one that flew, is 1.01. So there's 1.01. 1.02, and then the Soviet space program, they made a lot of improvements between 1.01 and 1.02. So the third Buran was 2.01, and that one's in pieces. That one's in pieces in Moscow somewhere, if I'm remembering right. I think that one is in Menino. Menino is a huge aviation museum outside of Moscow. Have you seen the TV show The Americans? No, I haven't. Plus, there was a wing design that Russia had. Yeah, Zonic, the flyback Zenits. That would be cool. It'd be great with the shuttle landing facility, dude, don't you think? SLF would be perfect for that. Can you imagine 4 Zenit boosters flying in a pattern? The ballistic coefficient is so low on those boosters because they're mostly empty, because they were mostly fuel. Can you imagine the boosters staying in a thermal in Florida and just circling and in a pattern like air traffic, and then just all coming in on the runway and landing? 4 of them just landing on the runway? That would be... Dude, Florida's perfect for that. That's why... Dude, I want Buran's boosters, and I want the American shuttle. That way you get everything back except for the external tank. Shut up and take my money! Yeah, right. Saw a great quote on Twitter in reference to the dance caught on camera the first in second stage this morning. It wasn't 200 years ago that humankind had a hard time separating a horse and buggy on a sprint. Yeah, homing pigeon, indeed. So we're waiting for a satellite deploy here. They're going to pulse the second stage engine here to increase the apogee of their orbit. What does that mean in plain English? They're gonna boost into a higher orbit. But you got to remember, in spaceflight, pulsing the engine once will take your orbit that's a circle and make it look like an egg. You got to fire the engine once to raise one side of the orbit, and then you got to fire the engine again to raise the other side of the orbit. Now, here's the thing. They're not doing the raising the other side of the orbit. They're not doing the second firing. Why? Because the satellites have thrusters on them that will do that second burn, and they'll circularize up at 500 kilometers. If you notice, right, the altitude of the booster is 207 kilometer right now. That is 120 miles up. That is a parking orbit right there for the second stage. Basically, this is an orbit that will naturally decay. It is not a stable orbit. That's what a parking orbit is. So if something went wrong, Jeb forbid, right? If something went wrong right now, the stage would just burn up. It would just come back down. I mean, we're not hoping for that. We don't want that. But if it did, that's what this parking orbit is for. 120 miles circular, because that number isn't changing. That's how you know it's circular. It's a zero eccentricity orbit or near zero eccentricity, meaning it's a perfect circle. That's not stable. There's still atmosphere up there at 120 miles up. It's just not enough to breathe. But there's still air pressure up there. So the stage is experiencing some perturbing forces from the atmosphere. There's air molecules that are bouncing off of the stage, nitrogen and oxygen and stuff. So it will eventually come back down. So what they're going to do here is they're going to boost this sucker up into space. And they're going to boost it, raise one side of the orbit, raise the apogee, make their orbit slightly eccentric. So after the burn, that altimeter, the altitude indicator, will start going up, right? And they'll probably deploy at maybe 300 kilometers. And then they'll deploy the satellites, and the satellites will orient themselves, and they'll boost the other side of the orbit themselves. This way, SpaceX can dispose of that second stage and make less space debris. Because if they push the stage up to 500 kilometer circular, or 550 I think is sun synchronous, if they pushed it up to 500 kilometer circular, the stage wouldn't come back down for a long time. That's not a decaying orbit. It is a decaying orbit, but years instead of a couple of days, like what it is now. So the reason why the SpaceX doesn't do the second part of that circularization burn with the booster is so the booster can deorbit and come back down. Or if it fails to deorbit, it will automatically come back down and it will burn up in the atmosphere. The stage doesn't have any thermal protection systems on it except for keeping the propellants cold. Nothing to survive re-entry heating. It'll burn the whole thing. And that's what they're planning for. Does that drastically reduce the satellite's life? Driados, yeah, probably more than you'd expect, yeah. But they're CubeSats. CubeSats and small sats aren't designed to be up there for very long. They have a very low shelf life. They're designed for the maximum amount of science yield in a very small time. Compare that to a satellite like James Webb. James Webb is a very big satellite that's going very far away. That is not a high yield of science in a short period of time. That is a pretty damn good yield of science over an extremely long period of time. 10 years due to our friends over at Ariane Space. Salud. So, Driados, it's always a trade-off. It always is. Do you want good space environmentalism and shorter satellite life, or do you want longer satellite life and more junk up in orbit? It's a trade-off that you have to pay for. Huh. Oh, they had a reacquisition of signal, and the stage was at 537.
Welcome back to the Transporter-3 mission, our third dedicated rideshare mission.
You need a
Falcon
better
9
mug.
lifted off at 10:25 a.m. Eastern from Cape Canaveral Space Force Station. Had a
Why? So I can buy a Chevy one that'll break after a year because it's made out of cheap plastic? Yeah, hard pass.
second stage burn. We're now waiting to relight the MVAC engine on the second stage for the second and final burn. It will be a quick burn lasting only 2 seconds. and we're anticipating that to begin in just a couple seconds.
Or you can buy the Mopar one, which works really, really well, but it's extraordinarily complicated for what it does, but it performs better than every other mug, but it'll still end up breaking. Oh, there's the stage ignition.
And shut down.
All right, as we saw
Quick
there
pulse
on
there.
your screen, like I mentioned, only a 2-second burn.
So these numbers that I said previously were a little bit off, because the reason why that number showed 200 kilometer. Okay, guys, all right, I made a mistake. I read these numbers incorrectly. So the mistake that I made was because they didn't have a good acquisition of the telemetry on the stage. This number went up from 200 to 500 on stage reacquisition, on the reacquisition of signal. They have a tracking station at Diego Garcia over here. Upon reacquisition of signal, that number jumped up to 500, which means what I said about halfway circularization is wrong. Driados, particularly because you had a question about that, I want to make it clear that I read those numbers incorrectly. What SpaceX is doing with this is at main engine cutoff, they did the first part of that circularization, and then that second stage burn is the circularizing burn. So now that stage is 536 circular, pretty much. It's gonna stay. It's up at 550 kilometers. Now, what I was saying, like, okay, so the stage will still decay up here, but it'll take a lot longer. But my guess with this is that it'll still decay at 550, but it'll take months up there. But SpaceX will do a deorbit burn. The reason why I think they're going to do a deorbit burn with this, even at 550, which will take a long time to come back down, is because they have a lot of fuel left over in that second stage, most likely. All these small satellites are really light. And that's further evidenced by the RTLS burn. If the Falcon 9 has enough fuel, first stage has enough fuel to go up, come back down on a polar trajectory and land at the launch site and not on a drone ship, right? That second stage probably has a good surplus of fuel for a deorbit burn. So this is a slightly different trajectory than what I was talking about before, but it has the same outcome. Basically, I used the wrong formula, but I got the right answer with those numbers before. But that's because they didn't have good signal telemetry on the vehicle, so these numbers weren't moving because they didn't have a connection to the thing. There's no, they don't get 5 bars down in Antarctica, from what I understand, even when you're in space. Sorry for asking, but what is this mission for? This is a rideshare mission, dude. There's a bunch of small satellites on this thing. Here, I'll show you. There's a shot of the. Let's see if I can get you a shot here. Give it a second. There's the first stage landing. Where's the deploy? There we go. Watch. So that's a picture of the second stage right after it got put up into orbit. So this is a rideshare sudden kill. See these rings right here? Those are payload attachment fittings. They're radial PAFs, though. So they're an RPAF. So what does that mean in plain English? Basically, this is a huge column of metal, and it's a hollow cylinder that's attached to the front of the front of the second stage, and there's a bunch of satellites that are radially attached to it. See all these satellites? They're all attached on these different posts right here. These are all a bunch of small satellites from a bunch of different companies. This Transporter-3 mission is what's called a ride share. There's no one big satellite riding on this payload or a stack of the same satellites like a Starlink mission. This has a bunch of small satellites from a bunch of different companies. Basically, all these companies pool their money together and they buy a launch, right? The idea is that you buy the aggregate space on a Falcon 9. And it looks like SpaceX had extra space because some of these payload attachment fittings don't have a satellite on them. See, that one is empty. But it's just literally a Christmas tree, and the decorations on the Christmas tree, so to speak, are a bunch of small satellites. And we might be able to see some footage of deploy coming up here. Yeah, it's a ride share, or basically the equivalent of carpooling. Yep. Yeah, where multiple people take one car. Instead of 4 people taking 4 different cars, that's more expensive, right? Because every car has to pay for gas, right? Or you could put 4 people into one car and pay for less gas, right? Because that's less mass to move. Unless it's your mom, in which case it's not efficient. Sorry. My bad. Oh, why?
Alpha Pod 2, separations confirmed.
Me mum, swearing me mum, mate. Transporter-3, great movie. Yeah, it does. I understand you're looking for a transporter.
Hi.
Hello, Primo.
The Oculus box in the front closet. Is there an Oculus in it?
Negative.
Okay, because it's heavy, so I wasn't sure.
That was weird. Space news. What's that, John? Rocket Lab USA may expand U.S. manufacturing and launch operations in Accomack County. Good. That's good, John. Good, good. Why you know have Oculus and Oculus box? Because it's right there. Well, it's behind the green screen, but I gotta start doing that again. We should do more VR now because we're doing variety right now. So okay, we do have a live shot here. Opinion. What's that, Forge? VR racing again? Yeah, I'll probably end up doing it. The problem is I can't see chat because I have one display on I have one monitor on the headset that the VR. Please call the Bondulins. I'm having a stronk. I have one monitor on the computer that the VR headset is plugged into, so I can't overlay chat, or else chat would be overlaid on the screen. I don't want to do that. Making
Alpha
progress.
3, separations confirmed.
Okay, another SEP confirmed here. Look at all the deploys coming up. They're just popping off all those small satellites on the payload attachment fittings. Maybe we'll see them. Yeah, Forge, that looks good. Yeah, they had to stop construction at that stadium. There was a football game last week. There are programs for 3D chat that you can move around in. Yeah, lols. It's just kind of one of those weird hardware bottlenecks that I have. I'll have to mess with it more, but kind of tight. Yeah, it's all right. Is the Lego shuttle worth it? I got my school one. I mean, Airborne. The Lego shuttle is cool, and the Hubble that it comes with is really cool.
ETVA 1, separation confirmed.
Okay, we got another SEP. Hopefully, we get some pictures here.
EPSO 1, separation confirmed.
Okay. Yeah, it's cool. I mean, I bought the shuttle and it literally sits on it sits in my dining room on a shelf, and I haven't touched it.
Separation confirmed.
I haven't touched it since I built it. But also on the other hand, I walk past it every time I come in for work, so I get to see the Lego shuttle.
It
every
was
day.
at 1, separation confirmed.
And I'm not going to sit here and tell you that it doesn't make me happy. Really cool space news. Sorry for the PM. Oh, Gunganyan progress. Nice, Toaster. You didn't need to whisper me that, dude. Just ask for link perms. So basically, Massey is gone.
New X1, separation confirmed.
Following decision awards.
Row 5, separation confirmed.
Forge, the fact that Mercedes whined so much to get a referee or a steward from Formula One removed from his position pisses me off a little bit. Just shut up and take the L, you whiny, whiny, whiny bastards, man. It's ridiculous. Oh, sweet. Nice shot. You can have Windows in VR so you can like place a chat window inside the car. Yeah, I know. Yeah. It would be a project for my son and I like we did for the space station. Do they have the extra lights yet? Extra lights? Why do that, EJ, when you can get complaint? Yeah, I mean, roundabout, it's no secret that they got hosed, but where was this outrage when everyone else was getting hosed so you could win? It's kind of pathetic, actually. It's making me lose a lot of respect for Mercedes. Like, wow. Like, I was pretty like Lewis at the end of the Abu Dhabi race was like, yeah, we'll get him next time. And I was like, oh, that's cool of you. And Toto was like, yeah, we'll get him next time. It's no problem. And then they start whining.
Pod 2, separations confirmed.
And they start whining, and then they got Massey removed. That's stupid. That's pretty pathetic. Look, man, you know, I watch a lot of American football, and roundabout, you know this. You know that the refs
Pod 4, separations
the refs
confirmed.
make stupid calls all the time, but I wouldn't want one of them to be removed. That's part of the game. Why are they not?
Pod 1, separations confirmed.
Why are they not showing them deploy? I'm not sure, Dad Boy. I really wish we had a picture here. Toto was absolutely furious. Yeah, and then he was partying that night, jumping into pools and crowd surfing. Balxy, was it really that big of a deal? It's pathetic. It's pathetic. Yeah, Mercedes, bunch of sore losers, dude. Now, don't get me wrong. I ain't a Mercedes fan, but you guys, Mercedes fans, Mercedes got hosed. They did. It was a terrible call. But once again, where was this outrage? Where was this outrage prior? Oh, there was one. We saw one deploy for a second.
Separation confirmed.
Where was that outrage when Red Bull got hosed, or Ferrari,
separation confirmed.
or anybody else? It's only.
Separation confirmed.
Oh man, they're deploying like crazy. It's only a travesty when it happens to you. That's pathetic. Literally, they're literally.
2, separation confirmed.
Mercedes is literally the emo kid. Oh, we got hosed. We got robbed of a championship. Oh my gosh, they need to change the rules because we got robbed. Yeah, shut up.
Hey, baby.
Yeah?
Could I borrow you for 10 minutes to help me move boxes from the front closet downstairs?
Are the boxes empty?
Kepler 17,
Yeah.
separation confirmed.
I mean, you're gonna have to give me a second. They're deploying.
2, separation
Oh,
confirmed.
oh, I forgot there was a launch. I'm
Yeah,
sorry.
yeah. You're gonna have to give me a second on that
That's
one.
fine, I can wait.
Okie dokie. Yeah, funky butt. Yeah, it's
Aurora Tech, separation confirmed.
making me not like Mercedes.
Super Dove, separation confirmed.
Super Dove. What a great name for a satellite. I saw it. I saw it out of the corner of my
Super
eye,
Dove,
guys.
separation
Oh,
confirmed.
there we go. Oh, hey! Yeet! You see
Super
the
Dove,
things just like-
separation confirmed.
These decouplers for these satellites are literally just springs. They're just a latch and a spring, and they let it go, and the spring decompresses, and it shoots the satellite off. So if they tumble around and stuff, that's totally okay. That happens. Yeah, it's pretty gross, Forge. Yeah, Blues, I'm with you on that one. Dude, but it's selective outrage at best.
As you may have noticed, we heard 24 of the expected 26 deployments.
Kate, you all
Again,
right?
we were not expecting to get all deployments confirmed in real time, so we'll work to confirm with our
Hello?
teams and provide an update a bit later in the webcast. In the meantime, the next 37 deployments are going to happen during a blackout period, which basically means that we lose camera views and telemetry. While we wait to regain access to ground station coverage in a few minutes, sit back and follow along with our animation that shows you where we are in the mission. We'll see you back here at T+1 hour and 15 minutes.
Okay, it's gonna be a couple minutes here. Yeah, Forge. Of course. Of course I had respect for Mercedes, but once again, selective outrage at best, dude. What, no Russian ground stations? I don't think so. Yeah, Isvik, that's what I don't like. Like, Red Bull got hosed at Jeddah pretty bad. Lewis and Max were racing each other, and they gave dissimilar penalties between Lewis and Max for literally the same thing. It's really annoying. And then there's that whole, Lewis almost killing Max at Silverstone. Yeah, that whole thing. Just a 10-second penalty, huh? Oh, okay. Okay. Yeah, Blues, I gained a lot of respect for Lewis, but it seems like he's just as whiny as he usually is. That's why I don't like him. Everything's great when you win. When you lose, he always blames somebody else. It's annoying, man. I can't stand it. I've hated him for a long time. Even before he started winning, he always whined, dude. When he was racing against Jensen, when he was in McLaren, he always whined every single time. When Jensen beat him, oh, well, you know, it's not my fault that Jensen beat me. It's the team. Like, dude, shut up. Oh, I'll check out the ASAP report later, Thomas. So I'll lose it, for sure, Jim. I miss Rosberg. Yeah. It's same with Nico. When Nico won, Luz blamed everybody else but himself. Nico's a better driver. Yeah, Malls, you live and die by the sword. Where was this selective outrage when it was going in their favor? There wasn't any. Hey, you live and die by the sword, man. You can't. The stewards can't be great stewards of the sport in one race and then bad in another race when the call doesn't go your way. That's what being a sore loser is. I like it when Lewis destroyed Alonso in 2007. Yeah. Hey, human, what's going on? To be honest, Red Bull did better the whole season, and no one can blame them. You know, everybody's like, oh, Max is a reckless driver. Max is a reckless driver. And don't get me wrong, his racecraft is probably not as developed as Lewis's is. Lewis is a great driver. I'm not, you know, I don't like his attitude, but he's a fantastic driver. He's literally one of the best. He's up there with Schumacher and Fangio, in my opinion, but, you know, like, and I don't even like the guy, but you can't deny the talent. You really can't. And you can go and sit and say that it's the car. That's fine. Sure. But he's won a championship with McLaren, too. Like, he's a pretty damn good driver, man. Kerbin's looking good? Indeed. That's not Kerbin, though. That's Earth. This is Human Space Program. HSP, not KSP. Yeah, Balxy, it's gross. Yeah, Funky Bot. Yeah. Mm-hmm. I mean, Lewis is good, man. He's a good driver. But you can't blame Max, like, trying to use every possible way to get in front of Lewis, because he knows that if he tries to pass him, like, legitimately, Mercedes will just complain. Like, that's what happened, and that's what they did at Jeddah. That's exactly what they did at Jeddah. I think Max had enough of that. And I think the FIA had enough of it too. Like, dude, stop whining. Go, pull out of the sport. Who cares? Piss off. You're ruining it. Yeah, probably, Forge, yeah. I missed the launch. They've gotten too frequent for me to stay on top of them. Well, they're going to be back in 2 minutes, so I'll show you a replay. Forge, all you got, or not Forge, Human, watch this. This is what you got to see right here. So, rocket's going up. It's going south-southeast out of Florida, right? So, oh my goodness.
Eco.
Stage separation confirmed.
Human.
Back startup.
I don't hate that.
Stage 1, boost back.
What were we talking about? Screw Formula One. I want to talk about this. Not screw Formula One. I love Formula One, even though I hated that everybody complains. But
screen, second stage and back engine has
hands.
ignited.
Sorry. I was controlling the mouse.
Is performing the boost back, which, as you saw just moments ago.
So two things to look. Everybody looks at the first stage. So the first stage separates from the second stage. You see the second stage ignition. Second stage goes, right? You see the first stage fire its nitrogen thrusters here. And it turns around, and then it fires its engine to boost back and land at the launch site. But I made it a thing to mention that this thing is flying south-southeast right now. It's going towards the Bahamas. Watch the second stage. Watch the ground relative to the second stage at stage ignition. The second stage takes a huge right turn, and it takes a right turn to follow the coast of Florida. Watch the stage, and watch the terrain around it. See, first stage, turning around. There's the nitrogen thrusters. Priming the engine right there. Engine ignition. Okay. First stage boost back is good. Second stage ignition is good.
On the right-hand side of your screen.
Watch Florida. See, Florida's going out of shot. That means the stage is taking a right. Because in Florida, they can't just launch due south. If they launch due south, the rocket is going to fly right over Miami. You don't want that, because if something goes wrong, you don't want the rocket coming down in Miami. That would be not nominal. Yeah, that's the right word. Not nominal. So what they do is they fly out eastward, south-southeast, right, a little bit, and then they turn that second stage, and that flies down the coast of Florida, which is really cool. It's a really awesome trajectory. It's Miami. It would be fine. I mean,
the first stage
no.
over and is now making its way back to the coast of Florida.
And then, human, watch this. It's very rare that we see supersonic retropropulsion from the business end looking up. Watch this.
Stage 2.
They don't want that Miami heat. I see what you did there.
Stage 1 entry burn startup.
Watch this.
And there on your screen, we can see that that entry burn has begun. Once again, this burn is designed to slow the booster down.
Look at that. So you can see it's kind of out of shot here, which is a little annoying, but the tracking camera guy did okay. All these shots are manually tracked by a guy on a trackball, by the way. Yeah, it's pretty crazy. You could clearly see there's 3 engine plumes right here, 1, 2, and 3. And what this is doing, and once again, the only reason, I'm going to say it's supersonic retropropulsion. What this is doing here is, as Falcon 9 gets back down into the atmosphere, just like anything else that re-enters, it's going to experience a lot of heating. Okay? You're going to experience a lot of heating. The Falcon 9 first stage doesn't have any heat shields on it. There's no tiles, no heat shields, no ablators, no nothing. It doesn't have that. So how does it get through? How does it get through the re-entry heating? Well, this is an idea that NASA came up with, believe it or not. NASA came up with this idea for landing stuff on Mars. If you fire your rocket engine at the plasma that accumulates from air compression and entry heating, right? It pushes the plasma away. This is called supersonic retropropulsion. The engine exhaust right here is the heat shield. That's the heat shield. The engine's outgassing, right? So the rocket engine fires, and it literally pushes the plasma out of the way. Plasma accumulates on the vehicle, and it kind of stays there. It's really annoying when you're trying to re-enter a spacecraft. It stays there and accumulates, and so you either have to have a very blunt nose cone, like on the space shuttle, that pushes it out and away, or you need to have a heat shield that basically straight up can deal with the heat. An ablator heat shield like what's on Dragon, right? If this is the bottom of the heat shield, the plasma just kind of stays there, right? It doesn't move. It just kind of stays there, and the heat shield gets heated by the plasma, and it burns away. It uses what's called ablation, right? An ablative heat shield. The thing is that when the heat shield burns, it burns and releases colder. It's still burning. It releases colder gas. And that colder gas basically puts the capsule in a funnel of cold gas that protect it from the heating forces. The rocket's exhaust is that cold gas in this particular scenario. Now, I know what you're saying. Well, aren't rockets hot? You got to remember, engineering is about, it's relative, okay? Are rocket engines hot? Yes. Yes, they are very hot. Don't get near one. Don't touch one after it's fired. No, don't do that. But is the rocket exhaust as hot as re-entry heating? No. It's actually, re-entry heating is way hotter than the rocket exhaust by a pretty significant factor. So firing that rocket exhaust is actually shielding the vehicle in a cool column of gas. Now, don't get me wrong, it's still hot because it's rocket exhaust, but it's not as hot as re-entry heating, and that's enough to get Falcon 9 to punch through the atmosphere. That's its heat shield. You're looking at it right there. And that's why this is a cool shot. That's why I wanted to show you guys this. That's the heat shield.
Booster down as
it's pushing the plasma away from the vehicle.
The atmosphere.
And as a result, the first stage doesn't burn up. And then by the time they shut the engines off, you're in the atmosphere and the grid fins take over. It's really freaking cool. That was an idea that NASA came up with. NASA actually helped SpaceX develop this because NASA had an idea of using supersonic retropropulsion for landing stuff on Mars.
It begins
That's where the
just
idea
before
comes
touchdown
from.
and provides the booster a soft
That
descent.
might just be the coolest thing I've learned this week. It is the most metal thing ever, Warrior. I love it. I love explaining it. That's my favorite part of Falcon 9. It literally fires fire at plasma to get the booster to get through the atmosphere. You're shooting flames at plasma. That is the most metal thing I've ever heard. How big are those grid fins? About the size of a coffee table, Moose. Like 4 feet by 6 feet, maybe. Big coffee table. They're titanium. They're one-piece cast titanium. Now, if anybody here knows a little bit about metalworking, I'm going to say that again. One-piece cast titanium. You know, that grid fin cost as much. One of those grid fins cost as much as like a Formula 1 car or something. It's ridiculous. One-piece cast titanium. That's not cheap. We got pictures from on right there. Oh. Entren, viewer that watches, got a picture of the Falcon 9. This is EPF right here. Oh, hello. Yeah, see all the gases? It's pretty cool, huh? In this picture, you could see the rocket exhaust is distorting the atmosphere because it's giving off a lot of heat energy. Just like any combustion engine would, gives off a lot of heat very quickly. And you can see the heat moving up around the vehicle. This is kind of a good example of what's happening during that entry burn. It's pushing the plasma out and away. But that's a great shot by Snake right there. You gonna take a break? No, I'm gonna keep going, K3. Isn't firing plasma so fighting plasma with plasma? No, it's fighting plasma with fire, Penta. Hot gases. Yeah, pretty nuts. Show this pose. Is this the simulation of SSRP? Yeah, see? Check this out. Chris Coombs is a professor at UTSA right there, working in hypersonics, which hypersonics means you're going very fast. This is a simulation of what supersonic retropropulsion does. Falcon 9 does something very similar to this. You fire the engines at the plasma, and it creates a thermal barrier, and it pushes the plasma out of the way. The plasma being right here. In this particular scenario, you see it literally pushes it away, like a fan would push air away. Same thing, but going like Mach 10. Yeah, it's pretty awesome. Let's go over here. Did I miss deployment? They should be deploying right now. So that second stage is on the northern coast of Greenland, up near the North Pole.
Ukrainian satellite Stitch. Separation confirmed.
Stitch. Yeah, it's really freaking cool, man. And then, actually, that's the deployment. And then I wanted to show you guys.
Falcon lands.
I want to show you guys the landing burn. So see how this camera is kind of jiggling around? That's the aerodynamic forces being exerted on the vehicle. The load that's getting put on these grid fins is crazy. These grid fins create a ton of drag. They're basically... Oh, wait a minute. I didn't notice that before. Watch the left grid fin. Look at that. So this shot's really cool. You know why? Because it looks like it hit a little bit of humidity right there. The grid fin hit humidity. And what the grid fins do, what any control surface that flies through the air does, is create differential pressure. That's it. That's all airplane wings and control surfaces do. They shift differential pressure. They make differential pressure. So an airplane wing has high pressure on the bottom, air traveling at low speed, and low pressure on the top, air traveling at high speed. That's Bernoulli's principle. That's very, very basic stuff. You're creating a pressure differential between the top and the bottom of the surface, right? Now the grid fin, because the grid fin is pointed down, right? It's pointed down, and it has a bunch of small, basically, control surfaces here in a waffle iron configuration, creates all kind of differential pressure.
Discovery, go at
and
throttle.
see how there's like rays of condensation right here and rays of low pressure? Because it hit the humidity. It looks like it's hitting the humidity in the lower atmosphere in Florida, right? Only 10 months from nice. Full high res from Transporter. But you see how this control surface has a lot of low and high pressure all next to each other? See that? That's how the hypersonic control surfaces work. You can't have one big rudder. One big rudder at high speed, like if it was like an airplane control surface, it would just slow. It would honestly just be a speed brake. But this is a control surface, like an elevator on a plane. An elevator on a plane steers the plane and changes its direction. The grid fin shape is because it's designed to create that differential pressure at a much higher speed. And you could see the differential pressure. You can physically see it from the condensation right there. See how it's splitting up the air? It's very interesting. Does it have anything to do with going subsonic? Maybe. Love how fast that computer in that thing recognizes the change of atmosphere and automatically corrects. It's a hell of a piece of kit, isn't it, Mighty? Something go wrong? No, Jacobs. It's really interesting to see. Like with a regular wing, you have low pressure and high pressure, and that's it. High pressure on the bottom, low pressure on the top. If you reverse that, it's a spoiler, like on the back of the car. Low pressure on the bottom, high pressure on the top makes downforce. Reverse that, it creates lift. Right? That's why the wings that are on the back of the car aren't wings. They're called spoilers. Wings don't make downforce. If a wing is making downforce, that means your plane's upside down. Probably, unless you're Tex Johnson, probably not a good thing. But you can see how this control surface being a completely different shape, look at it. It's splitting up. It's splitting up and creating high and low pressures interspersed with each other. And that's why it can control at hypersonic speeds, because of the way it cuts through the air. Yeah, there you go, Pythos. Full high res from SpaceX. Is the pressure acting as a catalyst to make clouds? What you're seeing is condensation, Invoker, from gases going through pressure change. When you go from like low pressure to high pressure, or high pressure to low pressure, right? So high to low pressure, note there's no gases forming in front of the grid fin. When you go from high pressure on the front of the grid fin to low pressure on the back of the grid fin, you get a massive pressure drop, right? And that pressure drop causes condensation. Yeah, those are called shock cones. It's really interesting stuff. This is supersonic aerodynamics. Well, to be more specific, it's transonic aerodynamics. But even a car that's not or a car or a plane that's not going faster than the speed of sound, or even near the speed of sound, will still have some pressure change. Going from high to low pressure and low to high does weird things to the air. Yeah. Ask Chuck Yeager about that. Well, you can't anymore, but you get what I'm saying. How did the launch go? Great. Like driving at higher speed and holding your hand out the window. You're literally just generating lift, Micro. Yeah. You ever do that as a kid? Synchronize wing flaps. That's just generating lift. You're compressing air on the bottom of your hand. And that air compression here creates low pressure on the back of your hand and makes your hand go up. That's Bernoulli's principle in its purest form. That's what makes planes plane. That's what the Wright brothers did with their plane. They made a lot of pressure change and the plane went up in the air. Oh, that's so legit. And now, this is cool. This is my favorite part of this, other than the supersonic retropropulsion. Look, as the rocket gets back down and hits that humid Florida air, the rocket engine is so hot, it's heating up the water vapor in the atmosphere and actually turning the atmosphere into steam. Look at that. That's not something you see every day. Notice how the steam is only occurring outside of where the pressure change is. It's literally heating up water vapor in the atmosphere and turning it to steam. That's ridiculous. Is that nuts? That's so damn cool. Now, that doesn't happen all the time because humidity changes all the time in Florida. Mostly just from absurdly hot to oppressively hot, but you get the idea. Last, please. Hey, Mari, 39-month resub. The plasma is purple. Yeah, yeah, that's probably right, Hellfish. Yeah. Those aren't nuts. Those are engines. You're right. And see, now, because it's going slow, these control surfaces can't shift the pressure enough because the air hitting them is not enough to create a huge pressure change. So at lower speeds, you don't have that pressure change because, well, you're not moving the air fast enough over this thing, right? Because you're not moving the air fast enough over it, doesn't do anything. So now the rocket is totally reliant on the thrust vectoring. Watch the engine here. I'll play this in slow motion so that people can see it. Here, watch. Ready? Now, give it a second. Yeah, when the grid fins no longer do anything, right, because the rocket's going so slow, thrust vectoring takes over, and it's like balancing a pencil. It's like balancing a pencil on your fingertip from there. That rocket engine needs to make a lot of minute corrections to get that thing to land dead center, but watch, it does it. Are the legs electronic or are they gravity propelled? Gravity, Sir Moose. I can tell you about them in a moment. So what happens is that there's a little pneumatic latch, and the pneumatic latch opens, right? And there's little flick arms that push the legs out, and they push them only a little bit, and then gravity takes over. Now, the legs aren't powered. They're just on a hinge. But the legs are attached to a pneumatic gas strut. See these things right there? Those are pneumatic gas struts. The trunk of your car or the hood of your car, you ever open it and it goes tss, and you have those two gas struts that hold the hood up or hold the trunk open or the deck lid open? Literally that. That's what those are. They're just as big as a car because Falcon 9 is huge. And they want to stay in the open position. And then at the end where they connect into the leg, there is a... See, the thing is that there's no suspension on Falcon 9. There's no suspension on the thing. What they have is a crush core. The crush core is acting as the suspension. There's basically like how a car in a front impact would have a crumple zone. Like if you look at a newer car, when it hits the wall, right, the engine compartment compresses and the passenger compartment doesn't compress so the people don't get skewered by a steering wheel, right? The crumple zone is at the very bottom of the landing of the gas strut, and it's an aluminum honeycomb. And if Falcon 9 hits the deck too hard, it'll just crush the aluminum, and that will absorb the shock. That's the suspension. Unfortunately, it's a one-time use thing, but crush cores are easily replaceable. Guess where they got that idea from? It's almost like doing rocket landings on Earth and on the Moon is kind of similar. There are aluminum crush cores in the landing gear structure on the Apollo lunar lander. True story. How do you think they'll mount those bad boys on the side? What do you mean, Exotic? My dog loves it when you make that sound. Nice. The gimbal lock rewatch. Yeah, here. We'll take a look. Yeah, see? Look at the gimbal doing work. Pretty much everything goes back to the Apollo days. Modern rocket science. Oh, that was CRS 16. Yeah, that's an extreme scenario. That's one that had a malfunction with one of the grid fins, and it landed in the ocean. SpaceX actually recovered that thing. They towed it into port floating like that. The rockets actually, as they drain their propellants, they have to keep pressure in the tanks or else the rocket will crumple like a soda can. Like if you have an aluminum can, I mean, that thing's aluminum. It's just a big version of this. It's an aluminum lithium alloy on Falcon 9, but same concept. Can you crush a soda can when there's no pressure inside? It's very easy to crush the thing. Can you crush one when it's full, when it's pressurized before you open up the top? A lot harder to do. The rocket uses pressure inside of the tanks to maintain structural rigidity. So as they drain fuel, they pump gases into the fuel and oxidizer tanks to keep the pressure. The fuel tank on a rocket and the oxidizer tank, they have to bring the oxygen with them. So there's an oxidizer tank. There's no air up there. True story. they're actually pumping helium into Falcon 9 as the pressure drains. So the pressure, or as the fuel drains, so the pressure inside of the rocket fuel tank and the oxidizer tank never changes. It stays constant. That's called ullage gases. Yeah, ullage. Like saying that word. So Falcon 9 actually, when it landed in this, it floats. It floats just fine because the tanks are literally full of helium. And they're airtight, because if they weren't airtight, they wouldn't be watertight and you'd be leaking propellants out the side. Probably not a good thing. So yeah, that's why it can float. Floats just fine. Yeah, that was 1050. Booster 1050 right there. Look, it's funny because the saltwater spray is hitting the engine nozzles and it's turning to steam immediately. See that? Lasts for the floating as well. Nick, 12-month resub. Thanks for feeding all my things Space Geek need. Oh yeah, nice. Yeah, no problem. Oh, this is coming from John. John Gadarowski. This is cool. Look at this. Caption contest, Falcon 9 floating plastic Blue Origin pad. All right, let me put us back on the live feed here. Oh, that was it. It looks like they got all the deployments in. Let me just make sure. Let me just fast forward a little bit. Look at that. Look at that, coming up over Hudson Bay right here. Oh, we're still in slow-mo from looking at the landing footage.
Mission. Now, when we came back from the blackout, we heard confirmation of those 37 payloads that were deployed during the loss of ground station coverage. And you just heard the call-outs for
I'll get to you in a second,
another
Taco.
19. Now, as you may have noticed, we were unable to confirm 2 of the 82 deployments. Because the spacecraft on this mission are small sats, and because there was a large communications blackout during the deploy sequence, it can sometimes be difficult for us to confirm deployments in real time. I'm hearing from our teams that we likely won't have those confirmations in the next several minutes, so we're going to end our live broadcast and we'll provide an update on those final confirmations via social as soon as we receive them.
And they just did.
Thanks again
Cool.
For watching.
Congratulations on a good mission, SpaceX. That was amazing. Fantastic, dude. We do have another rocket launch today, guys, by the way. We'll be back for that coverage at 5, so in about 5 hours from now. The next rocket launch for the day, at least tentative, I don't know, they might go, they might not, is a rocket that launches into space off of the bottom of a 747. So if there's I'm pretty sure there's a live stream for that. We confirmed that yesterday. We will be covering that here. Yeah. I don't know about you guys. I want to see a 747 launch something into space, please. Yeah, that's going to happen later today during our space news segment. Yeah, it's a really awesome launch pad. It's a really nice piece of GSE right there, ground service equipment. Booster 4 outer engines got their covers today. Cool. Yeah, Pegasus style. Indeed, Gandalf. Yeah. I mean, I love 747s, but TriStars are also... TriStars are... Yeah, it turns out when the people that designed the SR-71 try to make a passenger plane, it turns out really, really well. Yeah, that S-duct, though. Oh. Hey, that flew over Lompoc the other day. This thing? Or the 747? I mean, either one is cool. Yeah, that's right, Ernok. Yep. The 747. Cool. Yeah, Stargazer. This is the other. This is called a stratolaunch technique, where you launch a rocket off of a plane that goes into space. This is one of 2 active stratolaunchers right now. That's the other one right there. Nice launch pads. Except doing maintenance on that tail engine is annoying. I mean, doing maintenance on an SR-71 must be annoying too, but I don't see anybody complaining about that. So does that plane have a separate APU? The APU on this? It has to. Lockheed wouldn't not have the APU. So when auxiliary power units aren't on the back of the plane, well, you can't put it on the back of the plane because there's a freaking engine there. When they're not on the back of the plane, they're usually in the belly. So look around for an exhaust vent. There's one right there. The APU could be right here. That's where it is on a V-22, for instance. Kind of a different thing, but here, let's learn. Lockheed TriStar APU location. I actually don't know. I would guess that it has to have the APU. Where's the APU in the case of an S-duct like the L-1011? The APU is located in a compartment underneath the S-duct in the aft fuselage. Did Google just say Lockheed TriStar for sale? No, I haven't been Googling that. Shut up. Yeah, you guys got it. It's just below the engine. Still in the back. Yep, see, there's your exhaust. Yep. What the hell are those? As the white boys say on the internet. What are those? Seriously, I don't know what those are. What? Does that have that? Does he know about this? Yeah, see, that one doesn't have it. Strange. Sensors, it's the UK tanker. Oh, do we have a refueling boom here? I don't know. There's the back skid plate. There's a little deployable plate back here that prevents a tail strike, I think. Oh yeah, there it is. Yeah, right side. And this is actually, there's something here that a lot of people don't know about. Actually, wait a minute. I can't tell if it does it. Does this have variable AOI on the rear elevators? It might. Can't tell. It kind of looks like it does, but looking like it does doesn't mean anything. Telltale sign of an APU. Black and metal grill with soot trailing behind it. Yeah. Pythos, you think these things have variable angle of incidence on the back? So sometimes planes can move the elevators up and down like this independently of the control surface right here. That's the elevator, and this is the horizontal stabilizer. Sometimes planes can move the elevator and the stabilizer like this. That's called an angle of incidence. Angle of incidence change. You do that to help trim the plane out and help keep it stable. Yeah, see, angle of attack is different than AOI. AOI is angle of incidence. That's specifically. Yeah, that's specifically referring to this. Please help James Stronk having bondulins. Yeah, cool. And
Discovery, go at throttle up.
Those bypasses, though. Thanks for the exhaustive research. You're welcome. Don't do that again. I'll allow it. Call bondulins and having strong. Kind of want to build airplanes now, but I said I'd play GTA, so. Max Q question. Yes, Taco. Thank you. Let me check. What did you say? Hang on. There's another question that's up there too. Dex, will there ever come a time when we have too many satellites and debris in space and that it's overcrowded? Yes, that's called Kessler syndrome. It's important to make sure we clean up that stuff. Space environmentalism is not like it should be taken very, very seriously. Don't get me wrong. Environmentalism down here should be as well, but sometimes people get overly dramatic about it. It's just something that we need to do. There's no need to be dramatic about it, right? However, polluting space is a little bit different than polluting down here. But yeah, debris can get too saturated up there that we couldn't be able to launch anything into space. It's called Kessler syndrome. And yes, that's not open for interpretation. That if you've ever seen Gravity shows what happens when there's too much space debris up there. Satellite hits another satellite, that creates a cluster of debris. That cluster of debris is basically a shotgun blast that hits another satellite, and then that causes a chain reaction, and they hit two satellites, and they hit two satellites, and then there's just a big, nice cloud of crap floating around Earth. Yes, that is absolutely a thing, and we need to figure out a way to mitigate debris in the future. Anyway, Taco, your Max Q question. Question about Max Q. I know this is the point at which the most dynamic pressure, there's the most dynamic pressure on the rocket. After this point, is the pressure on the rocket decreasing because the atmosphere is beginning to thin out and thereby there is less to be compressed against the rocket? Yeah, exactly. The way I like to describe dynamic pressure or maximum dynamic pressure on a rocket, Taco, is like this. It can't move the air out of the way fast enough. The air at higher pressure, like, okay, so picture yourself like on a rowboat in a pool full of molasses, right? You're going to row, and there's only so much you can row before the molasses just kind of sticks to the front of the boat, and the boat can't move it out of the way anymore. Now, keep in mind, that's hydrodynamics versus aerodynamics, but that's basically the idea. The rocket is going so fast that the air actually can't move out of the way fast enough, and it compresses against the top of the vehicle. It compresses in the same way that you would like push down on the vehicle. That's why those dynamic test stands that SpaceX has at Boca Chica, the one with the soda can in it, right? It's not the soda can, it's the booster test article. It's designed to mimic that compression force resulting from aerodynamics. So, yeah, you pretty much got it right. But yeah, how I describe it is the rocket can't move the air out of the way fast enough. But it only happens for a second. There's only a certain point in a rocket's ascent where the dynamic pressure will stay up there. But what rockets do, because if you're compressing a lot of air, I talked about air, talk about change in pressures here, in pressure drops. If a lot of air is being compressed up against the front of the vehicle, what is that going to do? If air is being compressed up against the front and then lower pressure air is moving around the vehicle, it's going to cause drag. And that is not good for the rocket. Rockets need to go through the atmosphere. They don't need to stop in it, right? That's not efficient. So they throttle the rocket engines down so that air can basically get moved out of the way. It's at the expense of going fast, right? But believe it or not, keeping the rocket engines pegged on the limiter, so to speak, will actually make a less efficient trajectory. True story. Best joyride. S-duct water slide. Nice. There's a lot of stuff up there, guys, but yeah, don't worry. It's not anywhere near catastrophic failure. But yeah, Kessler syndrome is a thing, and that thing does exist. We've got to be cognizant of that. Like I said, that's the Space Force helps with that. Space Force helps catalog and track debris. And it's not just the U.S. Space Force. The Russians do this. The Chinese do it. Europeans do it. The Japanese do it. Everybody tracks the debris. It's very important to be a good space environmental steward, because if you're the one that makes a lot of space debris, and your space debris hits another guy's space debris, that other guy's going to get mad at you. And that could end poorly. So it's important that we work together, and that's like, you know, tree hugger stuff notwithstanding, right? You really don't want to be the guy that screws that up. Nobody wants to be that guy. That's why there's such huge like proliferations for people that want to use rockets to cause mischief, like around the world, right? We try to make sure that you understand the tech that you're dealing with and don't just want it so you can blow somebody up. The other option is to make the noise pointier, but that's more mass on the rocket that you can't use for fuel. Yeah. What are we playing later today? Well, constant monitoring, 24 hours a day, 7 days a week, 365 days a year, Tien. Everyone does it. Believe it or not, there's a strange kinship in space. Everybody says that, you know, oh, space is really difficult. Now, I like to say why space is difficult, right? Like, that's what I like doing. But it turns out that when you're in space doesn't care if you're Russian. It doesn't care if you're American. It doesn't care if you're Chinese. It doesn't care if you're European. It doesn't care. It doesn't care. Everything in space is constantly trying to kill you or damage your equipment, literally at all times. Yeah. Yeah, it's funny because it's real enemy of my enemy stuff, right? Like, we launch spy satellites. The Russians launch spy satellites. The Chinese launch spy satellites. But everybody knows to keep their distance in space and not be that guy, right? Which is very funny to me. You know, it's like, oh, down here we hate each other, but up there everybody hates space because it's annoying, because it's a pain in the butt. So it's a pain in the butt because it impedes us from spying on each other. Hilarious, right? I guess that makes sense in some weird way, right? Like, I mean, Earth doesn't care either. Yeah. Well, how I like to explain it is that, you know, down here we like PvP. Flying up into space is PvE. We shouldn't PvP in space. That makes a lot of debris. Yeah. Anytime, you know, I watch The Expanse and I see them fire off those gun turrets, like on the ships in The Expanse, they have like machine guns on the side of their spaceships. I'm sitting there going, you don't know how much debris you just made. It's PvE. Yep. You got any news on KSP2? No, nothing as of late, Alpha. Last episode at midnight. Oof. All right. So, has collisions already happened? Yeah. A Russian satellite and an Iridium satellite collided a couple of years ago. Well, not a couple of years ago, a little while ago. Yeah, it didn't end well. It created a lot of debris. Now, keep in mind, this is slightly over-exaggerated. You want to see how much debris it made? Here, look. This is a site called stuffin.space. It's a relative approximation of all tracked debris in space, or tracked satellites, I should say. This doesn't track like pieces of debris that are small. This is just the satellites, right? The Iridium-33 Cosmos 2251 collision. All those red dots are pieces of trackable debris from one satellite hitting another satellite. Yeah, we're lucky that didn't create more debris. That happened in the 2000s. Yeah. And keep in mind, this is a slight over-exaggeration. Slight over-exaggeration. This is designed to get the point across. All these red dots are little pieces of debris. Yeah, that's what I mean about PvE. Look, there's already enough things that break your stuff and want to kill you in space. All right? There's already enough. We don't need to contribute to that difficulty. And that's why the peace kind of is kept in space by all the major superpowers. Everybody understands that this is a pain in the butt. That, for instance, is why you don't want like they don't want like North Korea to get a missile and go and try and hit a satellite or something. Because, yeah, great, you proved that you could launch a rocket, but now you're screwing things up for everybody, including your allies. That's why, you know, nobody's like, okay, great, yeah, you did another missile test. Just, nope, you don't want to do that. So they're all in widely different orbit. Is that because of the precession at different altitudes? Yeah, and two colliding satellites, Jonas, tend to create a little bit of a tangential velocity. So a little bit of column A, a little bit of column B. But yeah, that's all the track debris. This is the kind of stuff that the Space Force in the U.S. deals with. They deal with tracking all this garbage. Like I said, the Space Force can track stuff down to like maybe the size of a wrench. And there are wrenches floating around up there from astronauts that went to put down their tool and tool just floated away. It has happened. There's also a glove up there. A couple of gloves. A couple of other things. Yep. This is why, for instance, people are worried about like Starlink. Now the Starlink satellites, that's a lot, but these are all guided pieces of equipment that's not just unguided debris. Unguided stuff is the stuff that's really dangerous. All these satellites have thrusters on them, and then when they almost are out of propellants, they deorbit themselves automatically. That's why SpaceX needs a huge fleet of reusable Falcon 9 so they can keep this network maintained. And also, these satellites are in a decaying orbit too, so even if they did become debris, they would deorbit. They would automatically burn up in the atmosphere because of physics. Even up at 550 kilometers, guys, there's still atmosphere up there. I wouldn't take your helmet off up there. That probably wouldn't be a good idea. You'd suffocate. But there is still enough air to cause drag. It causes pressure change, even up at that altitude. Yeah, true story. So the Starlink satellites, if one hits another one, God forbid, if one hits another one or one breaks and it just becomes unguided, it'll come back down in a couple of weeks. Yeah. Think of these Starlink satellites like how a submarine works. Submarines aren't neutrally buoyant. They're constantly sinking, believe it or not. Yeah. Submarines are constantly sinking. They use a bow thruster or a bow plane thruster to keep it neutrally buoyant, so I should say. Like if you let all the controls go on a submarine, it would just nosedive into the ground, onto the ocean floor, right? That's what would happen. These Starlink satellites are the same way. If one of them dies, it'll just come right back down, which is actually pretty cool. That's pretty smart. That's a good way to mitigate debris if you're trying to build a 3,000 something satellite network. So they're flying underwater. Well, it's not flying. It's, I guess, floating, I suppose. It's, they use a bow plane thruster in the same way that a plane would use the elevator. Yeah. Submarines, like I said, submarines are constantly sinking. You can't, it's nigh impossible to make a submarine perfectly neutrally buoyant, so they don't even try. They just make it so if you let go of the controls, it'll just, and then they trim out the controls with the bow plane so the submarine goes straight through the water. Yeah, I mean, like I said, they have a bow plane on them, and once again, some of them have like an elevator in the back, like an airplane. Like if we look at a Russian Akula, which is a Russian attack submarine, it has the plane thrusters in the back. They trim that control surface out, just like the Stargazer would. Same thing, but swap out aerodynamics for hydrodynamics. Water works a little bit different. Yeah. The reason why stuff floating through the water and stuff flying through the air is a little different is because water is, for the most part, incompressible, and air is compressible. Big difference. We can do a lot with the ballast tanks, more than you'd think. I mean, John, yeah, you could say that, but I mean, one of my buddies from high school, his stepdad was the commander of an attack submarine. I'm not going to say which one or where or when. He tells me that's right from him. That's right from the guy that commanded a submarine. So, I mean, I'm sure they could probably trim it out with computers to get it close, but it's never going to be perfectly neutrally buoyant. And that's, once again, right from a submarine commander on an attack sub. At low speeds, water and air aren't very different. The way they flow, the flow visualization delta is the same. Right, yeah, it's close, but there are two sides of the same coin, I should say. Yeah, I like aerodynamics. Aerodynamics are cool, but hydrodynamics are pretty cool. I just don't delve too much into hydrodynamics because if I go Googling information on how a submarine works, I'm pretty sure that's not going to end well. I'll just stick to rockets. But then again, Googling about rocket engines too probably is not a good idea either, now that I'm thinking about it. Let's go read about submarines sometime. The deep sea stuff can be neutrally buoyant because water is actually a tiny bit compressible, about 10% denser in the Marianas Trench. Yeah, but are there submarines that go down there? You are on the list. Yeah, probably. I tell you guys about the time I showed up at Edwards Air Force Base to go check out Armstrong Flight Research Center and they knew who I was? True story. I gave them my name and they're like, huh, Eric Johnson's already in the system. And I'm like, what? They're like, oh yeah, you're already in the system. I knew why I was in the system. Because you don't get to go on Cape Canaveral Space Force Station and not be in the system. That's why I was there. But it turns out it was the same system. So, yeah, pretty cool. Hey, Econ Greg, thanks for the raid. Give me 1 second. I'm talking to Brimo. Clips. If I ever work for NASA, I'll let you know if you're being watched. It's the Air Force, but I was on the Air Force's list. But yeah, Clips, I got you. I mean, they know who I am, so kind of a big deal. People know me. I have many leather-bound books. Give me 1 second. NSA, not NASA. Oh, okay, yeah, I gotcha. What's going on, Econ Greg Raiders? Hey, Greg, thanks for the raid. I appreciate it. Good Transporter-3 launch from SpaceX. Really awesome. What's beyond our galaxy? Is there another Earth? Yeah, there's plenty of crap out there, Clips. Oh, yeah. Beyond our galaxy, there's other galaxies. And there's a bunch of galaxies orbiting in the universe. And the universe is as far as we've been able to see. As far as we know, I don't think it gets bigger than that. Unless it's like the end of Men in Black, where we're just a marble where our universe is just a marble in the huge alien marble game, which would be kind of cool. So we have Earth. Earth is rotating around. Earth is orbiting around the sun, and a bunch of other planets and a bunch of other crap, to be honest, is orbiting around our sun, and that's a solar system, and so that's a star, right? And then there's plenty of stars orbiting around the center of a galaxy, and the galaxy, there's a bunch of galaxies rotating around the center of the universe, which is where the Big Bang was. Clips. I'm pretty sure that's how that works. I mean, the scale here is ridiculous. The scale here of us even trying to go to like Mars would be like an ant trying to cross the Atlantic Ocean. We're talking about scales that are incomprehensible to the average person. Like, unless, you sit there and explain it. Like if I say, oh, we're going to go to Mars, I don't think the average person can really kind of quantify how far that is away. And also the target's moving. That has a lot to do with it. Galaxies are just expanding into vastness. They aren't rotating anything. Yeah, Scott, I'm not the best at this. I'm not the best at that stuff. I'm really better with like practical orbital mechanics. It's from playing too much KSP. But then again, my knowledge isn't just from KSP. I started doing it in KSP and I got interested in it and then I started reading books about it. So, yeah. Yeah, I'm not just saying, well, I'll have you know, I play KSP, so I'm a master of orbital mechanics. Yeah. I hate it when people do that. And the funny thing is, the people that say that, I probably have like 6 times the amount of hours they have in KSP than they do. I would never flex KSP as a reason why I know about spaceflight. That's ridiculous. Who would do that? I have a question about James Webb. The sun shield is there to keep the telescope cold. But how is it different than a sun sail? Is it too small to be pushed out of orbit? It's not different than a sun sail, Violent. In fact, it's susceptible to solar winds. Just like any other sail. It's a giant solar sail. You know how they compensate? Dude, you're going to like this. Watch. James Webb has a rudder. Well, elevator, to be precise. I'm serious. It has a rudder that's designed to deal with solar wind mitigation. It's that big panel at the back of the telescope. Yeah, it has a control surface designed to mitigate the perturbing effects from this basically being a giant solar sail. Yeah, they can change the angle of attack on that flap on the back, and to help keep the satellite position. Literally an azimuth thruster, or a control surface on the spacecraft in space. Yes, you're right. The sun shield is a big solar sail, and they have to compensate for it. Oh, thanks, Clips. I just like this stuff too much, dude. I would love to. I'd love to go work for them. That'd be sweet. Imagine blowing up a balloon with a bunch of dots on it. Every dot moves away from the dots equally, just as our local group of galaxies moves away from everything else. Yeah, of course, I gotcha. Yeah, it has flaps. Mm-hmm. Pretty cool, huh? Still giant solar sail, gets giant solar rudder. Yep. Those flaps are only usable when there's solar winds. That's correct. Solar winds are basically the exhaust plume from the sun. So the sun is at the center of our solar system, right? And the sun is bigger than every planet around it by a pretty significant margin, right? It has a lot of gravitational pull, but sometimes you get a reaction on the surface of the sun where you get a nice big explosion. It is a big fusion ball that's on fire, so sometimes you get a backfire from the sun. That's called a solar flare. And sometimes that solar flare is enough to break the gravitational pull of the sun. The gravitational pull, or the stuff that stays contained inside of the gravitational pull of the sun, is that kind of area is called the solar corona. Okay? And sometimes there's explosions on the surface of the sun that are so ridiculously violent it shoots the byproducts of the fusion reaction of the sun, which is ionic radiation. It's the sun's exhaust plume. It shoots it out of the solar corona. And that does have perturbing forces on satellites. That's what a solar wind is. There's also there's other perturbing forces coming from other stars too. There's galactic cosmic waves and stuff. There's all kinds of crap up there. Yeah. It is a very dirty place, despite what you might think. There's a lot of stuff going on. First of all, everything influences everything up there. Like James Webb is using precessional forces from the moon to stay in an Earth solar Lagrangian point, to stay orbiting around a Lagrangian point. It's really interesting stuff. Yeah, a coronal mass injection, or ejection, not injection. Injection's something else. I think SpaceX did that with the catch arms yesterday. The magnetic fields on the sun are really something. Yeah, we had something skirt the Parker Solar Probe skirted the solar corona a couple of weeks ago, or like a month ago, and it was fascinating stuff. How's that tile flap going to help? The solar winds, Violent, aren't going to push the satellite in one direction. Solar winds really aren't strong enough to do something like that, right? What the solar winds will do is cause the satellite to tilt. It'll cause it to spin. So, like, think about if you had, like, a piece of paper, and you put the piece of paper in front of the fan and you let it go. Is the piece of paper just going to do this? No, it's just going to spin out of control until gravity pushes it into the ground. Now, you don't have that pushing it into the ground thing. So the piece of paper will just... That's what that's for. It's designed to... That's what the solar wind flap is designed for. It's designed to prevent perturbing rotational forces on the satellite. Turns out when you're taking a picture with a camera, you have to keep it still. That's what that's there for. It's to prevent the thing from doing this. It's to prevent it from tilting. Rumors spreading around that Texas town about that shack outside Lagrangian Point. Y'all know what I'm talking about. Yeah, Lagrangian points are weird, man. So Lagrangian points are neutral points of gravitational pull in space between two celestial bodies. So in this particular picture, not to scale, the sun is, if the sun was in this picture, it'd be the size of the blue line. Actually, probably bigger than that. Like, actually way bigger than that. Maybe the surface of the sun would look like a straight line comparatively. But just bear with me here. There's neutral points in gravitational pull. So there's a point where the gravitational pull from Earth cancels out the gravitational pull from the sun. And something, it's like a tide pool for gravitational pull. And something can just stay in L1. Or something can stay in L2. That thing. That thing is, James Webb is on its way to L2. This is Earth, solar, L2, right there. Cool thing is that there's a lunar, there's Lagrangian points between Earth and the moon. There's lunar Lagrangian points too. This is a good visualization of gravitational pull here. The taller this topographical thing down here is, the more gravitational pull you have. But yeah, there's neutral points in gravity. And it's, like I said, like a tide pool for gravitational pull. You can kind of just put stuff there. And as long as you add little maneuvering thrusters or a bow or tail plane like that, something can just indefinitely stay locked between those two celestial bodies. It's really, really interesting stuff. Yeah. James Webb is going to L2, and it's orbiting around L2. You can orbit around these neutral points in gravitational pull if you know what you're doing. It's really, really, really cool stuff. It looks like a peace sign. Yeah, the hippies finally got something right. Just kidding, but not really. Is there one between the Earth and the Moon that they could put a station in? Yup. Oh yeah, absolutely, dude. Yeah, ULA is talking about... ULA has a plan... tentative, right? They might do it. It depends if the money is right, of putting a gas station at L1. Yeah, a refueling depot at L1. Because, yeah, that would be good. That means you don't need to send a spacecraft in all the way out to the moon. You send it to L1, which is, you don't need to be going as fast, right? It's less delta V to get to L1 than it is to get to low lunar orbit or the surface of the moon. If you have a little reusable refueler that can mine the ice on the moon, right? And then Saboteur, right? You get liquid hydrogen and liquid oxygen. Send that up and just park it at L1. Yeah, send that up, park it at L1, literally put a koozie around it. And you have a gas station at L1. And you can, just like a gas station on the highway will extend the range of your car, right? That will do the same thing. Physics is physics. Doesn't matter if it's a road trip or a space trip, I guess. What would be the radiation risks that far out with humans? Not sure, King. That's what Gateway is all about. Gateway is something a little bit different, though. Gateway is in a rectilinear halo orbit, which is a rectilinear halo orbit around the moon, which... rectilinear halo orbits use lunar precession to be able to stay always in constant visual of Earth. So during the Apollo missions, right, the Apollo capsule went to the far side of the moon and they had no communications, right? A rectilinear halo orbit uses the non-uniform gravitational pull of the moon, because the moon is not a perfect sphere. And it's not perfectly uniform density throughout the entire thing. Neither is Earth, for what it's worth. And these little variations in gravitational pull cause perturbing forces on vehicles that are orbiting around it. These perturbing forces are called precession. So, King, now, the funny thing is like, okay, you send something to orbit around the moon in KSP, it'll just stay there, right? There's no atmosphere to make it come back down. It'll just stay there. In real life, there's decaying orbits on the moon due to this lunar precession. But there are certain scenarios and certain resonant orbits where it's using that precession to actually keep the orbit stable. The Lunar Reconnaissance Orbiter has been orbiting around the moon for more than a decade, actually 13 years now. It still stays there. It uses the precession to keep its orbit boosted, which is actually really cool. The rectilinear halo orbit uses lunar precession like that to basically orbit the moon. So like if the Earth is right here and the moon is right here, the moon's tidally locked, right? One side of the moon is always facing towards Earth. It uses the precessional forces there of Luna, of the moon, to basically stay in an orbit where the normal, so left and right, is always facing towards Earth. It's really, really interesting stuff. Check this out. So this is a video that was a visualization that was done by, I think this was a university study. Who did it? I forget. Well, they'll say, oh, here we go. Okay, so this is Johnson. Watch this. Yeah, there you go, Baranok. Yeah. So this doesn't do. This is hard to show. Like, you're not going to get that good of a visualization from this. It's the later animations in this video that will show you. So this is showing what's called a DRO. A distant retrograde orbit is a very high altitude, high semi-major axis orbit around the moon. But those perturbations, those perturbing forces are what give it that kidney bean shape. DROs are where Artemis 1 is going. The Artemis 1 Orion that's going to launch sometime soon, this year, I guess, maybe, is going to get put into a distant retrograde orbit like that. Note that the further you get away from the moon, the more kidney bean shaped your orbit gets. Weird, right? Now, rectilinear halo orbits are a little bit different. The rectilinear halo orbits use those same precessional forces that give that orbit its kidney bean shape to always be in constant line of sight to Earth. It's actually, like I said, very, very interesting stuff. So the right way, this might get a little confusing to look at. Look at this one. So this is a camera that's basically in line with the Earth and the moon, and it's rotating with the Earth and the moon. Look at the orbit. King, check that out. The station always stays coplanar normal or coplanar antinormal, depending on if you're on the ascending and descending node relative to Earth. It's always in constant line of sight. A rectilinear halo orbit never goes to the far side of the moon. Or does it? The moon is still spinning, but the spinning takes a lot longer of a time because it's always facing towards Earth. But that rectilinear orbit, the rectilinear orbit basically makes it so you could, at some point, if you shift this NRHO orbit and you go into low lunar orbit, right? So like say a lander, like Starship, goes down to low lunar orbit and just circularizes there. Now you're in just a regular polar orbit. So now if you wait a little while, you could get to the far side of the moon. The reason why NASA wants the gateway out there is because it's basically an access point to anywhere on the moon. You can literally land anywhere. You can land at the poles. It's already lined up for it. You could land at the Apollo landing sites. You could land in the lunar basaltic regions, which is where the Apollo landing sites are. You could land in the lowlands. You could land in the highlands. You could land in craters. You could land wherever you want. Gateway gives you access to the entire surface of the moon, as opposed to a space station that's floating around the equator of the moon is only going to give you access to the equator. Now, you could have a polar orbit around the moon, like I said, but that polar orbit doesn't use the lunar gravitational precession. It doesn't use lunar precession. So eventually you'll go behind the moon and be in communication blackout with Earth. This gives you all the benefits of a polar orbit, and due to its high eccentricity, uses those perturbing forces to always stay in line of sight to Earth. So when people are out there, they're always going to have a constant connection. They're always going to be able to communicate with mission control, which is really smart. That's a really smart way to do things. So if it's behind the moon, how do they bounce the signals around since it's stationary? You don't, Arhoff. They didn't do it. There was a period during the Apollo missions where they were not in contact with the astronauts. Nope, on the far side of the moon. Nothing out there. There's no communication satellites out there. I suppose you could float one at a Lagrangian point, but you could do that, but we've never done it. We could in the future. We could put a relay satellite stuck in that neutral point of the neutral tide pool of gravity on the far side of the moon. You could put a relay satellite out there. Sure, why not? But they didn't have that during the Apollo missions. The Apollo missions went in there with nothing. It's just the antenna on the spacecraft and the deep space communications arrays that were on ships and tracking stations back on Earth. Crazy, right? I'm talking about James Webb. Oh. Here, I'll show you. This is really cool. All right. So, I never said that I said that James Webb is going to Earth-Sun L2, right? Now, Earth-Sun L2 is a little bit different, all right? It's not going to stay there. It's actually orbiting around that neutral point in gravity. I mentioned it, but I probably should have clarified. Here, watch this. So this is another video from NASA, right? How big is the tolerance for the Lagrangian point? How from the center point could you be for it to still work? You can orbit around them, Dan. Watch this. So, right, since it's using Earth-solar Lagrangian, not Earth-moon, there's EML2, which is right here in this picture. It would be right here. And then there's Earth-Sun L2, which is right here. It's a Lagrangian point between the Earth and the Sun. And now, if you know a little bit about this, the moon is going to come by every once in a while. It's going to get close to Webb. And when it comes by on its orbit, close to Webb, it's going to pull on it a little bit. That's lunar precession. It's using lunar precession just a little bit to help keep it in space, from what I understand. Watch this. And the result from that is not sitting at L2. It's orbiting around L2. Crazy, right? Space is righteous, man. That's so cool. Yeah, somebody thought of this. Somebody sat down and said, "Oh yeah, let's put it there. That's fine. Yeah, we could figure that out. No problem." I mean, it took 20 years, but that's another story. Yeah, pretty crazy, huh? That must be lonely on the far side of the moon, not being able to speak with Earth. Yeah, you got your buddies with you. But Bandit, think about this. So like during Apollo 11, Michael Collins was by himself on the CSM. CSM's still orbiting, went to the far side of the moon. So there were times where Mike Collins was truly alone with his thoughts. Can you imagine that? I mean, it was only for like 40, 50 minutes. But still. I don't know how I'd feel about that. That must be simultaneously the most peaceful and the most frightening thing ever. Better 20 years than never. Snake, yeah, actually I agree with you. I think now that we know how to make this type of technology, we should make more. We should like have a James Webb Space Telescope factory cranking one of these out like every year. If I had my way. I mean, it's like my old man told me one time, you don't think better than one crawfish dinner is 5 crawfish dinners.
Discovery, go at
Excuse me, when launch? You missed it. What happened to the launch? You missed it. When? Just now. When will then be now? Soon. But there's another rocket launch in about 4 hours. If not L2, where do you think the Webb scientists would have considered parking it? Where else makes sense? You could do something like this at the moon, Sile. You could do this at the moon, but the problem is that every once in a while, the problem with it is if you park James Webb here, there'd be times where James Webb is literally pointed at the sun, which is not what you really want. And like guys, this is a space telescope. It doesn't shoot visible light. It's infrared. James Webb is an infrared telescope, right? So non-visible light. But that doesn't mean that, just like if you were looking through a telescope, do you look at stars from a telescope during the day or do you do it at night? It doesn't matter if you're in space. You still need the darkness to be able to see stuff correctly. Like, it's tough to see stars and planets during the day. You could see the moon during the day. That happens. But it's much better to image stuff at night. And it preferably, in James Webb's case, and actually in any telescope's case, it's actually better when it's cold. Because when it's cold, heat doesn't distort the gases in our atmosphere and you can actually see further into space. Yeah, you get atmospheric light diffusion. Greg actually knows all about this, the guy that rated me. Greg's an astronomy streamer. All Greg does is stream pictures through his telescope live. It's really awesome, actually. Great friggin' stream. Yeah, Velk. Oh, man. Sorry for lurking so much. I don't care. You got to do what you got to do, man. I don't expect 100% of your attention all the time, Chief. That would be insane. There are streamers like that out there. And I kind of just tilt my head and go, okay. Is this image to scale? Hell no. If this image was to scale, the moon would be out here somewhere. Actually, it would probably be off the screen. The moon's about 250,000 miles away. And I forget what Earth's diameter is. But, yeah, I tell you, the moon would be about double the distance of my mouse cursor from Earth in this picture. And if James Webb was in this picture, it would be probably 1/1000th of the size of a pixel. Probably, and that's probably overestimating. That's probably too big. Diameter is 7,900 miles. So if that's 7,900 miles, the moon's supposed to be 248,000 miles away. So yeah, it's way over there. James Webb, you wouldn't even be able to see it if you could take this picture in real life. There's no way. You wouldn't be able to see it. You would need an electron microscope to see it if this picture was to scale. That's how big space is. But yeah, I hope you guys enjoyed that. I'm going to switch over to, you guys wanted me to play GTA, right? Just joking. Does Earth's shadow extend to L2? Yeah, it partially eclipses the sun, Baranok. Yeah, they do that to keep it cool. Mm-hmm. Yeah, Big Star. There you go. You guys wanted to see me, so more specifically with GTA, you guys wanted to see me build a racetrack in GTA and start messing with the editor. That's what we wanted for early hours today, right? I was working on building a racetrack late at night last Saturday, and people have been asking me almost every day, hey, can you do that more? Can you do that more? So I guess we're gonna go try and mess with the GTA editor. I've never messed with it before, except for Saturday. So let me get my controller out, and we'll try to build a racetrack in GTA. So I hope you enjoyed the SpaceX coverage and subsequent space discussion. And yeah, let's get